I'm under no illusions what we have in front of us, and the demands that's going to place on the business, on me, on every area of my life. And it's that fight that you've had to get to this point that gives you the strength and the confidence to know that you can see it through. So I'm a father myself now. I've got three boys, and it's really interesting. Even at a very young age, you can tell very quickly what direction people are likely to go into, and I see it in my own kids now. That there are character traits there that, without any influence from me, would lead them in particular directions. I've got one in particular that I think he just thinks like an engineer. And I think you'd probably say the same would be true of me. I can remember playing with a little lawnmower that my dad had made for me, and constantly trying to make things in the shed at the bottom of the garden and not being very good at it.
The one thing I can say is about Jace is if he puts his mind to something, he's 100% determined and it's going to happen, even from a young age. If he was playing football in goal, he would be cleaning his boots, washing his kit, washing his gloves. Didn't make him a good goalkeeper, but you could see from an early age if he was determined, he was going to give it 100%.
He watched Airwolf. Obviously, he watched Airwolf, and he didn't just watch them. He and his brother Kev were fanatical about it. They watched all of these 80s engineering type machines that could do incredible things, and there's no accident that he wants to create an incredible helicopter that can do incredible things, because certainly that 80s popular culture influence of what was on the TV at the time, certainly that has had an impact on HX50 for sure.
So I think I was sold on the excitement and the adventure that helicopters offer, and that Bell 222 that they used for Airwolf was a strikingly beautiful aircraft. Really attractive machine for its time, and that really got the hook into me. But it then developed from that, because then every time I saw a helicopter, I was craning my neck round trying to see what it was, and started reading about them and getting books out of the library about them and studying them, and it really grew from there. But I think with, like so many things in life, it's something will spark your interest, and then if that's the right thing for you, it will grow from there. And for me, just seeing this amazing aircraft doing amazing things, and that was probably the trigger point.
I think we've got to highlight the effort he puts in. It's not all natural ability and he could just turn up and pass an exam. He studied hard, and I think that was bred into both of us, probably from our parents, that if you want to do well in life at anything, you've got to put the hours in.
Up until that point, Jace had been, he'd done all right at school, and he was doing okay, and he was generally engaged, and his teachers liked him and all the rest of it. But there hadn't been anybody that had really ignited his imagination. And then Jeff Gillen turned up, and he was different to all the other teachers that he had. And the reason he was different is because he was a very straight-talking person, which I think reminded him quite a lot of his dad. And I think he'd also come from industry, so he hadn't gone about being a teacher in the normal route. And I think Jace really liked that, because he brought with him skills that Jace found were directly relevant to what he really wanted to do.
But that was the start of it, and I guess lots of people have got a similar story, that somewhere along the way there's been a teacher or a mentor or a professor or whatever that connected with them and made them believe that they were good at something. And that was Jeff for me. Jeff was the first person that made me realise that I could do this stuff really well. When I finished my PhD, I was obviously broke and needed some money. And I was also very aware, because I'd been working on the early versions of my designs for 2 or 3 years by that point, that to do this properly, it was going to be a big job. And so I built Dynamic up based on the skills that I'd developed working in aerospace and in various other industries to really provide that level of analysis and design capability and product development and troubleshooting capability. And we went and did that for almost 15 years across industries. You see, the funny thing about building a business is if you're good at it, it gets successful. And then when you get successful, it consumes all your time. So decades disappear if you're not careful. And it took a little while to get Dynamic to the point where it was successful enough to be able to support something like this. And over that period, we were chucking significant amounts of our revenue into the development of various areas of the project to develop the range of technologies, the range of capability that we needed to put the aircraft together. So yeah, Dynamic has been a servant of the helicopter project for a long time now.
He's really upped it a gear, and he's been even more driven than he normally is. And then obviously he shares stuff with us, and it's absolutely fantastic what he's achieved already. I think everybody will agree with that no matter what, but this is just the beginning, and I can't wait to see more.
He knows the market like nobody else. Like nobody else, because it's not just I fancy building a helicopter. It's an obsession, and that is the right word for it. A total obsession. It governs everything he's ever thought about in terms of his career.
I think we've got an enormous amount of challenging but exciting work to do ahead of us. But I think the outlook is incredible. I think the product is the product that people have always been waiting for, and I get customers tell me that day in, day out. I get sales prospects, people I don't even know, thanking me for taking this on and doing it. It's what they've always wanted, and so I'm very confident that the juice will be worth the squeeze. I think we've got an amazing opportunity. I think it's going to be a lot of fun. I think it's going to be very demanding, but it's exciting, and it's an honour to have been given this opportunity to deliver this. And I'm loving every minute of it. It's demanding, it's difficult, but it's so overwhelmingly fulfilling that I wouldn't change anything. I wouldn't change a single thing about the path we've taken and where we're going. So yeah, the future's bright for HX50.
Good evening, ladies and gentlemen. Wow. What an honor to be here with all of you guys tonight. We have people from 9 different countries represented here today, many that weren't able to make it, obviously with the restrictions and everything that we have. But when I look around, I recognize so many of your faces, and it's an honor to be in this room for the first HX50 Global Meetup and Discover event. As you guys just saw on the screen there, this has been a dream for Jason since he was a young child, since he was a kid. And what's exciting for all of us, I think, is, we have incredible stuff behind us. I'm looking at the tail fin of the HX50 right now, and the 1/3 scale model. So many wonderful things that we have here, physical things where this dream is coming to reality. It's coming to life. But what's beyond that, I think, is, more impactful for even Jason, but for Ruben and I as well, is all of you, because he couldn't make this helicopter without each one of you. And it's the support you know, it really is a club. It's the HX50 club, and it's the support of each one of you here that has made this dream actually into a reality. And so we just want to say thank you and a big welcome from all of us.
That's right. Big welcome to everyone. And it's so great to see you all. I've already had the chance to talk with so many of you. And we have seen you through our presentations, but the first time we're in person.
Yes.
So this is really the first global meetup and discover. Why? Because we want to mingle together, we want to network, and we want to discover a lot of things. So it's going to be amazing. I think you're going to enjoy it a lot. Just to give you an overview of the program, we're going to have a great presentation by Jason. And then as usual, as the culture of the company, we're going to have plenty of time for all the questions, okay? So we always, probably can remember, always say, no question is a bad question. Anything can be brought up. Is that true, Jason?
Absolutely.
Right, he's ready for it, okay? So we want to make sure that is...
so start thinking about those questions.
Absolutely. So you take notes of those during the presentation, and then we're going to be available for that. Then after the Q&A, we're going to have still more networking. We're going to have changing the menu. It's going to be dessert menu, so I hope you had the first menu. And then after, we're going to have some dessert. We're going to stay here around about 9:45, 10 o'clock. We're going to be closing. Okay, so thank you very much for coming. And by the way, I want to give a warm welcome not only to all of you, but we have more than 300 people already watching live.
Yes.
So great to have you all from all over the world. We have clients virtually from all the 5 continents. So thank you again. And Jason, he's the man, and he's the one that's going to bring the helicopters that I want to fly, Mischa want to fly, and everyone wants to fly. So Jason, thank you very much for making this happening through a journey of a dream. And please go and start the sharing of the Discovery event.
Thank you. Thanks, Ruben. Thanks, Mischa. Yeah. Ladies and gentlemen, welcome to Hill Helicopters.
Yes.
Yeah. So we're going to do this slightly differently tonight. I'm going to limit the presentation to talking about the 4 areas that describe what we've done essentially over the course of this last year. I'm going to talk to you about the vision for the company, the vision that we now all share. I'm going to talk to you about the strategy that we're executing at the moment. And then I'm going to give you evidence that we're delivering on all fronts across the program. And then we're going to finish up with talking about the shared benefits of bringing a manufacturer together with a community that wants this aircraft. So let's start by talking about the vision for the aircraft, for the business. You don't have to be great to start, but you have to start to be great. And everything starts with a vision. This one's mine. So that might have started off as my vision, but it's now our shared vision, a shared vision for how we can make general aviation better for everybody in the future. We're making an aircraft that's more capable, more desirable, more attainable, and more connected than ever before. And most importantly of all, everything that we do, everything that we've done is owner-centric. The whole business model is based on what private owners need. The aircraft is based on what private owners need, and that is what we're all about. And of course, if you get the vision right, if you get the big picture right, then it should be no surprise that big sales follow. And as of today, we've sold 342 aircraft in 38 different countries, and we have a 51% market share. We're outselling the R44 by 2.3 to 1, the R66 by 4 to 1, and the Bell 505 by 4.6 to 1. What we're doing is resonating, and we're truly grateful for the support that everybody has provided for us. We've got people in the room today that came into a very, very empty restaurant and had the courage to join us, the belief in the vision that we all share. And for those people, I personally will always be grateful. So thank you very much. If we talk a little bit now about the strategy, it's all well and good having these big ideas. It's all well and good saying we'll make it for a $5 and it'll be better than everybody else's. But you've got to have a realistic way of delivering that. And our strategy isn't a new idea. But it's absolutely central to everything that we do in design, in development, in manufacturing and upscaling, and even beyond that, into support. This has tentacles everywhere. And that's this idea of vertical integration. In the aircraft community, there's been a big move for these companies to stop seeing themselves as engineering companies and manufacturing companies and see themselves as technology companies. Manufacturing is the thing that you get other people to do for you. That's not how we see it here. Here, we're a manufacturing company. So our vertical integration strategy is really taking aircraft manufacturing back to how we used to do it, back to how the Spitfire was made. We make stuff in-house. What that means is raw material comes in through the front door, we add the maximum value we possibly can here, and then we send a premium product out to the front door. And what that means is we have absolutely total control over our cost base. And what that means for you guys is not only can we deliver you an aircraft at the right price point when you come to purchase it, but it also means that we can control the cost of spares, and we can make sure that the through-life costs and the through-life costs of support are properly controlled. It also allows us to control insurance and all the other things that we need to do to make sure your machine sustains its value proposition as it ages. Now, beyond all of that, of course, if you're going to go and develop a business to make everything, that's a big business to develop. And so a lot of what I'm going to show you tonight is about the journey that we're taking to develop the business as much as we are the components and the aircraft itself. So we're very busy at the moment investing in people, investing in processes, investing in fabulous plants. We've got a wonderful team from our suppliers here to support us, and they've been fantastic in this journey that we're undertaking together. But don't think that vertical integration is just about making stuff yourself. It's much more than that. If you've got a lot of development work to do, it's also important that you can control the costs of developing prototype parts, of iterating things when stuff goes wrong, because it will. You know, this isn't going to be a smooth ride the whole time. But the simple fact of the matter is, it's designed up there, we talk about it down there, it gets analyzed over there, and then they program the machines and we make it right there. Now, rapid prototyping doesn't get any quicker than that. There's no being beholden to other suppliers and outside firms that you've never got the volume to be interesting to. We can do it all here. It gives us complete control. And so that is really what underpins our ability to deliver an aircraft at the right price on a very sporty time scale, and to give you the confidence that we're going to be able to support and keep the running costs of these aircrafts really low into the future. So that's the strategy. And of course, what I need to do now is explain to you how we're delivering that and what we've actually delivered to date. So let's start with an overview of some of the precision machining stuff, which has been the big stuff that I've pumped out over the app over the last month or so. And the very first part of that is to have a look at the components of the engine that we're starting with. So the GT50 engine is absolutely crucial to the aircraft. The beauty of doing an engine and an aircraft at the same time is we can essentially design the aircraft that we want. So you start with how much payload, how much speed, how much performance you want, and that defines what the engine needs to be, not the closest thing that you can buy off the existing manufacturers. But of course, to hit the price point, we also have to be able to control the cost of the engine. And central to that is making our own compressor wheels, making our own turbine blades, making our own castings and casings, even making our own gears and bearings. And that really is what this first swathe of equipment that we've invested in is all about. So what you can see on the clip playing in the background is really a walk through the process that we use to manufacture the centrifugal compressor that delivers 2¼ cubic meters of air every second at 8 bar and then spits it out at nearly 400 degrees so that the combustor can swallow it and create power for you. And the way this starts is we bring in the highest possible quality material, and then we take it over to the lathe, and then once we've created a blank, like you can see here, that then goes and sits on the 5-axis machine, and we can start to cut away the teeth. Now, at the moment, what you can see here is some of the early process development work that we've done, proving the tool paths, proving the cutter strategies, just getting the whole thing to work properly. And that whole process has been done in less than 2 weeks. So it gives you an idea of once you've got the right people, once you've got the right equipment, you can do this stuff really, really quickly. And so what we'll do in a second is we're going to go over to the 5-axis machine, we'll talk about the key steps, and then we're going to get the machine moving, and you'll be able to see the 5-axis machine actually producing one of the very first compressors for the GT50 engine. So we'll have a look at that now. We'll let this one play out. I'll make my way over there, and we'll go and turn the machine on. Yeah. Is that finished? All set? Okay, so Mark. Mark is our lead production engineer, ladies and gentlemen. Please say hello to Mark.
Hello, Mark. Hello, Mark.
So as I've just outlined, we take raw material in through the front door, and then we've got to take it through a series of processes to be able to make compressor blades. So Mark, why don't you just tell us what's gone on here? What have we done here? What's this first stage?
So this compressor wheel consists of three operations across 2 work centres. That first operation there is it's done on the CNC lathe, which is a pre-op. It rosts the material out.
Okay, and so this is really just about getting as much material out of the way as possible?
Yeah, that's correct.
As fast as possible, okay. And then we move over to the second stage, and what's this operation done on?
So this operation is done on a 5-axis machine. That's a roughing operation, so that removes a very high amount of metal.
Okay, so we're really just trying to form the blades as quickly as possible.
Correct,
at this point. Okay, but they don't look very rough. They don't look very tidy. So what do we have to do next?
The final operation is a finishing operation, which gives you the surface finish and the sizing that we require.
Okay. Because, of course, for these things to perform, the tolerances have to be extremely tight, the rotors have to be balanced extremely carefully, and we require a surface roughness on here of about 1.6 RA. Otherwise, we simply don't get the aerodynamic performance that we need. So that's fantastic. The other thing that this machine does, of course, is this is the same machine that we use to manufacture our gears. So this is a partly machined spiral bevel gear out of the bottom of the main rotor gearbox. And manufacturing gears in-house is something we've talked about a lot over the course of the last 6 months or so. That's incredibly important because helicopters are very much machines rather than aircraft. So it's vital that we can do those things in-house. Okay, should we get the 5-axis running then? Okay. Yes. All set? Can you get in there? So what you can see here is essentially the start of the finishing operation. So we're moving from the rough blades towards the finished blades, and the purpose of a 5-axis machine is quite simply, it can take the part and it can swing it around whichever way it needs to so that the cutting tool can get access to the components that it needs to shape. Now, to put that in perspective, I'm sure over the years many of you have had to replace compressor wheels on various engines. this whole process for making the compressor is about a one-shift operation. So we can produce these in between 8 to 12 hours at the moment. There's not a lot of optimization being done on this yet. As I say, this process is 2 weeks old. And so that's the 5-axis machine. Got it. Let's move on from there. You can knock that off now if you like. Do you want to knock it off? Okay. You turn it off now, Mark. Okay. So let's talk about the gearboxes. So the 5-axis handles a lot of the most complicated parts in the engine, the gears, the compressors, and some of the fiddly things where you have to access the part from all sorts of different angles and directions. There are a lot of other things that are much bigger, that need equal levels of precision, but they're a little bit simpler. So if we take the GT50's speed reduction gearbox, the thing that takes the input from the power turbine at 36,000 RPM and then reduces that down to a more usable 5,500 RPM. Now we need to produce high integrity, lightweight gearbox cases that hold all of those gears in close tolerances to each other so that the gears run true and stand up to the life that they need, that they're going to see in service. Now, ironically, although the 5-axis machine looks really complicated and really clever, the manufacturing engineering that goes into producing things like our gearbox casing is actually much more complicated. Because the machine's limited to only being able to move in 3 directions, then we have to hold lots of work, create lots of work holding to hold the part on the machine, flip it over, and build the whole thing up with a series of different operations. Now, I think in one of my other videos I've explained, you can think of this machine not just as a machine that makes gearbox casings and blade tools, it's actually the mother machine. This thing makes a lot of the tools that we use to create wax injections for the casting processes. It makes a lot of the tools that we use to make blades. It'll make some of the composite patterns and tools that we'll use, as well as making finished components for the mechanical assembly of the aircraft. So if we just go back over, we'll have a look at how the gearbox casing is machined, and then we'll have a look at the 3-axis machine working in a similar vein. So, Mark, what we've got here is what looks to me to be a great big chunk of aluminium. So can you just explain how we make these gearboxes? What are the stages in producing this gearbox?
Correct. So it starts as a big lump of material. This is the first operation where we put the profile in. We put these series of holes in as well. We then locate on those holes and machine the inside, the inner side here.
Okay, so essentially it just gets clamped on the machine in a big vise to start with, but then you have to put these things in so that you've physically got something to hold it when you turn it over to machine that. Okay. Okay, and then once we've done that, how does it go on the machine? What does it actually look like on there?
Right, so once we've done operation 2, we then locate on the bore, and then we locate on the machine and machine the second side.
Okay, and those little tongs at the side, is that just there to hold it on there, or what?
Yeah, correct. Yeah, that's for clamping, and then they come off once it's all finished. Like.
Okay, smashing. Well, should we see it finishing off that part?
Okay.
Are you able to get any closer? Yeah. We'll just have a look and peer in through the window so that you can see what's happening. So for those of you that don't know a lot about machining, these things are really glorified cutting tools where the cleverness in the machine is about how you can position the cutting tool so the cutting tool can follow paths to sculpt out the things that you want to be manufactured from metal. And that'll go and machine away for hours on end until we've created the parts that we want. And that's essentially how your gearbox speed reductions casings are made, tools are made, and various other things across the platform. Okay, you're off. Thanks, guys. Okay, so the next example that I want to talk about is the rotor mast. Now, this is literally the part that we all hang off. So this has to be very, very high quality material, very, very precision, very, very tight tolerances, very close control on the surface finishes, because of course the mast is constantly subjected to cyclic load, so it's very prone to fatigue. And so what we're showing you here is really just the first operation in the mast manufacturing. It has a profile cut onto the outside, and then it has some spline features on the bottom and the top so that we can physically drive it on the top and drive it on the bottom. And then there's an equally precise operation required to bore up the center of the mast and cut away all of the excess material. So let's just go and have a quick look over here, and Mark can point out what we've got going on over here. So what state of manufacture is this in then, Mark?
So the whole profile's been turned, both ends on this one.
Okay, so essentially what we've got is the various shoulders and things that we need to be able to, all of the thrust for the whole helicopter is carried on that flange face there. There's splines to be added down there later and here as well, so that we can attach the main rotor and attach the driving gears in the gearbox. And obviously it's still quite heavy because we've got to bore the center out of it.
Yes.
Is that right?
Yeah.
Okay. And then there's not much point in showing you that one live because we can't get the camera in. So we'll come back to that one a little bit later. Okay. The one other thing I'll say while I'm walking around, of course, is the newest machine. This actually only arrived on Monday. This is our internal and external grinding machine, and this actually allows us to manufacture our own aerospace-grade bearings, okay? And the reason for that is because the cost of bearings in that industry are very, very high. When you're designing gas turbine engines, it's inevitable that you have to design special bearings anyway. So if you're going to design them and be the design authority, it makes sense that you carry that through and then also manufacture them. So that's the new boy over in the corner over there. Okay, next slide. So one of the defining characteristics of our aircraft, one of the defining characteristics of the user experience that we're creating for HX50 is our digital cockpit. We're trying to create a new modern flying experience where flying is simple and engaging, reduce the workload, make it as easy as possible for people to fly, as easy as possible for people that don't fly that often to get back into their helicopter and be completely current to the greatest extent that's possible, and just to make it as car-like and up-to-date as possible. Now, we provided the vision for that a long time ago. You've all seen the user interface, and since then, we've been doing a lot of work behind the scenes with the avionics architecture, with the hardware that drives all of this. And there are some very unique challenges with developing a digital cockpit in an industry that moves fairly slowly. The electronics industry moves very fast. So the moment you start looking for screens, you'll find that the screens are no longer in production after 3 years. So how do you support that? And what we've been doing behind the scenes is making sure that we can deliver this panorama of digital information in front of you in the front of the cockpit, but design that and deliver that in a modular fashion behind the scenes so that we can continue to buy screens that can be used as replacements for spare parts, and we can continue to support the aircraft as they age into the future. And so what this has meant for us, what this has led us to, is essentially you will have a monolithic piece of touchscreen glass across the front of the aircraft, totally unparalleled. Nobody has this. And that will actually be made up of three 15.6-inch screens behind the touchscreen that give us a huge amount of real estate to display big, bold, clear flight instruments and context-sensitive information. So you only get what you need when you need it. And of course, one of the biggest developments is that as we've gone to slightly bigger screens, it's given us the opportunity to put the the apps that you use to navigate, the electronic flight book apps, right in the center of the screen. And so that's something that we've been working on very recently. There are multiple configurations of the system that you can use. So you can use it as a pilot and non-flying customer like this, or when you've got a second pilot with you and you're flying two up, you can both have the flight instruments, you both have control of all the systems, and you conveniently have the app of your choosing in the center screen. Now that center screen, as you've probably seen over there on the demo, is bigger than the biggest iPad you can buy, okay? So it gives you great visibility, much clearer maps, much easier user interface than you've ever had before. And of course, we can then wrap all of the synthetic vision and the terrain awareness straight across the three screens. And we're just adjusting the user interface a little to disguise the mullions that you inherently get with modular screens. So one of the most recent things that we've done is, and I suppose this really sums up the culture that we have in the culture we have in the company, is when we were presented with this opportunity to host the apps rather than just requiring people to have an iPad in the center, we put that out via the app to the user community and asked for their opinions. And with the exception of a couple of very valid technical comments that we received back, it was a unanimous, yeah, let's just have an uncluttered cockpit. Let's just, as long as I can host my app, I'm happy. And so we've been busily over the last week or so taking the development screens that we've got in the lab over there and looking at different ways that we can host the apps that you all want to use. So let's go over and have a chat to Martin and have a look at the development screens, and we'll have a look at the user interface and the apps. Now, I'm sure many of you will have had a chance to come and have a look at this already, but one of the things that we're particularly pleased with the user experience is the fact that these gauges are really big. So you're talking about 9 or 10 centimeters across each of the primary gauges. So they're a lot bigger than what you would have been used to in conventional analog aircraft. You've got 3 4K screens that are extremely high resolution, crisp, sharp, bright colors, high luminescence from the back. And of course now we've integrated the moving maps, which I'm sure you can all come and have a play with later once you're walking around the show. So Martin, just tell us a little bit about the screens that we've opted for here, and the Avidyne box and what have you. How do we deliver all of this? So what equipment do we use to do that?
So the displays themselves are dumb displays. So they're LCD displays. So we need LCDs because we need high brightness. So we need 1,000 candela per meter squared, which is a really high brightness screen. So we can only get that through LCD liquid crystal displays at the moment. They are, as Jason said, they're 1920 by 1080 resolution, so they're very, very high resolution. Also with anti-glare and anti-reflection, which is very important for the pilot experience. But they are dumb displays. The clever stuff is sat behind it. So we've got a main processor box for the right-hand seat, and then another processor box for the left-hand seat. So this guy can drive 2 screens. The left-hand seat guy can drive all 4 screens. So that's including the IPI. Just a note on the IPI, you might have noticed, and some people commented, it's got a bit bigger from what you've seen. So we looked at the smaller IPI, which is about around a 5-inch, and we just felt that it was a bit too small. So we've gone that bit bigger, and Henry's had a challenge to integrate it into the center console, but he's come up trumps, and we're all delighted with that because I want a big IPI in the center console. What else? So we've also got a small intercom. So we have a blind intercom. So the intercom will be controlled through the touchscreen interface. So we obviously all your comms will be managed by the intercom, but you obviously manage through the touchscreen. So you won't have a dedicated control panel that you're reaching down trying to read. It'll all be up on the touchscreen. So the idea is that the user interface is as integrated as possible to keep your workload down.
Perfect, thank you very much. So what I didn't do when we started was introduce you. This is Martin Jakes, our Chief Electrical and Avionics Engineer. He's looking after all of this for us. Now on the subject of electrical engineering, would you like to tell us what this is?
That is a starter generator. This is a permanent magnet starter generator. This is a bit small for us. This is an 8.5 kilowatt starter generator. We're at 10 kilowatts. This one spins really fast, and actually shows that we're not actually spinning that fast. So this one spins at 120,000 RPM. So we're actually spinning at maximum 52,000 RPM. So the technology is there, and it's available, and it's operating today, and it's starting turbine engines today. We've got some. It doesn't look like much, but there's quite a lot that goes into this. So these are permanent magnet rotors. So these will sit in the centre of the starter generator and drive and start that engine.
Yeah. So for people that have seen the cutaway drawing of the engine, one of the things that's unique about GT50 is we've got rid of the biscuit tin gearbox at the front of the engine, and we direct drive the starter generator. So it's grossly simplified. We've only got two parts in the starter generator: the rotor, which just hangs off the end of the gas generator, and then we've also got the stator, which is the stationary part that collects all of the energy that this creates from the field disruption. And that's really all it is. That's the essence of your starter generator. No bearings, no lubrication, purely just two parts. And they're magnetic. And you may also have seen on a slightly related, I know, I'll leave that for Eric after, we'll come back to that. Okay, so that's the digital cockpit. That's where we're up to at the moment. We've got the user interface respun for the new size screens. We've got the apps up and running. We have a little bit of work to do with one of the favored apps for our friends from the US, but we're in active talks at the moment with the provider for that one. So I'm hoping that will follow very shortly. Thank you, Martin. Okay. Next slide. So, composites. Now, this is a big deal. So today, and actually, you're seeing this only about 10 minutes after I've seen it, because it only came up from Saltash this morning. As you're well aware, composites is absolutely fundamental to HX50. If you want a streamlined, attractive, high-strength, crash-worthy aircraft, and you have to go composites. Now, traditional composites are really very expensive to manufacture. They require very expensive materials, expensive tools, and then expensive processes to manufacture them. And one of the unique things about the way that we're manufacturing the fuselage for HX50 is, rather than going the traditional route of manufacturing using pre-preg, we're using dry fabric and infusion techniques, which is the way that they make boat hulls, it's the way they make wind turbine blades, and it's the way they make a lot of industrial composites. Now, there's no reason why those processes can't be applied to aerospace, and indeed, many of the big manufacturers are looking at them. But what we've done is we've taken that process and we've now demonstrated that we can produce a single-piece fuselage using this process. So what you can see behind, let me just say one other thing actually, the reason why that's important is because it makes a huge difference, not only to the piece price of the composite parts that we make, but also the capital that we need to be able to set up for composites manufacturing in scale. So this is absolutely critical to everything that we do within the company. The blades are composite, the crash cell is composite, the fuselage is composite, the boom's composite, and all the fairings are composite. So this is a core technology for the business. Now, the way that we've proven out this process and the way that we've proven that we can do it before committing to vast amounts of expenditure on full-scale tools is that we've produced the third-scale model that you can see over there. And the third-scale model is really there to prove that we can manufacture this component in a single piece. So that's what we've done, and that was actually only completed yesterday. So this stuff is literally hot off the press. And within our works group, we've been receiving daily updates from the guys down in Saltash and from Tim, our guy down in Saltash as well. And right at the end of the day yesterday, we got this happy photograph coming back of a pair of happy dads that had just given birth to their first baby HX50 fuselage. So let's go and talk to the happy father.
Good evening. Good evening, Jason. Thanks very much. And good evening, ladies and gentlemen. Welcome to Composites Corner. Whilst I've got the microphone, just a couple of introductions for the colleagues that helped produce the third scale proof of concept. We have Tim Searle and Stephen from Composites Integration, our resin infusion experts that held our hand through this whole process. But I suppose the real question is, how are we going to turn this dry fibre, which some of you have had a little play with this evening, into a viable composite structure airframe? We had a brainstorming session down at Salt Ash with our colleagues at Composites Integration back in, I think it was June.
Yeah.
And it was a really fruitful session. There was discussion about whether we should divide the airframe up into separate individual mouldings and then bring it all together as a bonded assembly, which I was pretty not keen on. Bond joints add a lot of weight. They had a point of a less reliable structure, and more importantly, they're very poor for load path. So getting the load path from the rotor head through into the airframe, we really want continuous structure. So I was pushing really hard to do it as a one-shot moulding. Tim was the cautious, careful now, don't overdo it. You know, we got to do this in a controlled fashion. So we came up with the idea of doing a 1/3 scale proof of concept. And so what you see before you here are the blue parts. That's the top mould for this crown section. And you probably can't see it with the camera, but in the background there's the floor moulding there. Basically that built up into like a blue coffin-shaped mould, which we put all the fibres up inside. We found a little trick to help us stick these dry fibres to the roof of the mould, which maybe Tim can expound on in a moment. We bagged it up. I put a pair of scissors through the bag, so we had to seal the bag again. And we infused the mould. It took us quite a while to set it all up because it's the first time we've done it. But the actual infusion process, you could see the resin rising up inside the part. 20 minutes to completely embed that moulding with the epoxy resin. And this is our first attempt, and we're pretty chuffed with it. We're very happy with it. It has metallic inserts built into it. It has foam box sections for the floor. It has all the structural elements that we want to capture in the real full-scale version. So maybe back to you for a moment. And
yeah. So I think the question I would then have for you, Tim, is, I mean, you're the resident infusion guru. This was quite a difficult thing to set out to do in the first place, wasn't it? You were very conservative when we started. How did it actually go on the day? I mean, how easy or difficult was it to hold the fabric, and how easy was it to get it infused? I assume relatively straightforward, because you brought one back when you first go.
I think that the key with this is really good preparation. Tooling is absolutely vital, and you can see the tools. Some of you have seen these earlier, but do come and have a look and prod them and have a good look afterwards. But we were really keen to take Tim's design, make a really good set of tools that we could mould off confidently. Now, the thing about this tooling system, there's 6 parts here. There's 2 sides. There's a top, a bottom, a nose piece which we couldn't fit in the van, which you've seen in the video. But all those tools have to seal together with complete vacuum integrity, because this process that has been described, by infusing liquid resin into this dry fabric, it's absolutely key that you get really good vacuum integrity. So we've got a vacuum seal that goes all the way around these tools that holds them together. And then we can confidently put a bag inside the tool that holds all the fabric in place, and all the preparation is done. All the carbon and some of the consumables are in place. It's quite a complicated shape, as you can see. And then when we've got that vacuum integrity, the resin will fly in, as Tim said, in about 20 minutes. Now on Monday, what are we now? We're Thursday. on Monday, there was no resin in this component at all. So on Monday, we'd bagged this all up, we checked for vacuum integrity, we'd got it all prepped up, and then on Monday, this whole assembly went into an oven, because we like to infuse the resin at a warmer temperature. So this is about 40 degrees centigrade. Remember, that's a lot less than the kind of pre-preg temperatures that Jason has alluded to earlier. And then on Monday afternoon, the resin was introduced. You saw it in the video. And 20 minutes later, all that epoxy resin has impregnated all this dry fiber, and then the resin begins its curing process. And then shortly after that, we were able to demold. So I don't think I've answered your question, have I? Which was, how did we get all the fiber to stick in the mold? Yeah. Well, that's one of the things that we set out to demonstrate, that actually this is incredibly challenging.
Yeah.
And actually, the idea is here that we build early. We build a demonstrator that ranks the problems, the challenges that are ahead of us. Because when we sat around a table, you know, some of the problems that seem really big are actually, they diminish a little bit when you try it. And actually then you're presented with a bigger set of problems which you've got to resolve. And so we've done that. And I think this has given us a list of things to refine, but actually we know that we can do it.
That's fantastic. Thank you very much. That's great. So, yeah, Tim and Tim, ladies and gentlemen. And Stephen.
Thanks,
so
guys.
I guess our very next challenge is how, once you've done this, do you ramp up to production? So what kind of kit are we going to need to be able to produce these in volumes? We've got an example of one of the machines that we've purchased here. Could you just talk us through what this does and how we use this on the shop floor to make Baby Fish's big brother?
Absolutely. So we brought along with us today an example of one of our standard resin injection machines. We'll be working with Jason and supporting him and his team in supplying some bigger scale equipment in the new year. And this piece of equipment is designed to inject the resin that Tim talked about into the fibers in the mold tool in a very controlled manner. So the equipment controls a number of parameters, including pressure, temperature, ratio of the combination of materials that are injected. And it does it in such a way that we can be incredibly confident in achieving a very high quality part with, I think it's fair to say, no porosity. Porosity is the enemy in these composite parts. And so we're very pleased to be able to share our expertise on the machine build side of this project. And when we do get into production, I imagine that we'll have eventually a number of pieces of equipment like this. And one of the beauties of the equipment is it's very highly programmable. It has an RFID scanning capability. The idea is that you scan the mold tool that you're going to be working with at that time. The machine recognizes the data that's been scanned from the tool and chooses the appropriate recipe and program, so we ensure we dispense the right materials at the right ratios, right pressure, right temperature, and ultimately get a good part.
Fantastic. So it gives us the control to really lock down the process and deliver the same thing every time.
Absolutely. That's what the equipment is all about, is control and quality.
Fantastic.
Every time.
Thank you. Thank you, guys, and congratulations. Cheers. Thanks, guys. Okay. That's Lydia. So, Helimove. We've hidden Helimove today because there wasn't enough floor space. But one of the other areas that you're aware of that's a unique characteristic of HX50 is we've tried to make the whole experience of owning and operating a helicopter that bit slicker. And there's nothing more deflatory than having to put your helicopter under your armpit and wheel it into the hangar like a wheelbarrow. And so our Helimove system is really designed to make it possible to move the aircraft into and out of your hangar and around on the ground using just your smartphone. So there's a lot of development that goes into making hub motor drives that are small enough and light enough to balance just the right degree of performance with the limits on size and weight that you have available to you for it to be viable for a helicopter. And to do that, we've developed the Helimove test rig, as you've seen, which is a fairly crude-looking piece of equipment. You can expect lots more of crude-looking bits of equipment from us over the next number of months. But this allows us to measure the torque that's actually required to get the equipment to climb curbs and to trundle over soft grass. And it also allows us to develop the smartphone app to allow you to just maneuver it and get it moving around on the ground. So the engineer that's been working on this for me, well, the two engineers that have been working on this for me, one of them's off skiing at the moment, and the other one is Eric. So Eric, if you'd like to just come and join me for a second. So you've got about the most piloting experience of all of us at driving this thing. I think the thing that most people are going to want to know is how easy is it to drive?
Well, you know, currently we have two ways of controlling it. We have using just kind of an RC airplane controller, and then also using an app on the phone. Now, the RC controller works great. It's very controllable. Unfortunately, with the app right now, due to some still trying to get the latency issues figured out. It's a little jerky, so still more work to be done on that. But it's yeah, it's really fun to drive around, and as you can see there in the video, it's been really good to do some testing and to collect some data that we can use to develop the
So in terms of the RC controller that you're using at the moment, how much training did it take you to learn how to use it? Was it something you could do straight away, or did you need to think about it a bit?
In terms of driving it?
To drive it, yeah. To be able to maneuver it on the ground.
It was very intuitive and didn't take much learning at all.
Fantastic.
And the app will be even easier.
Okay, fantastic. Well, we'll get it in the field now and go and get some data and measure it.
Sounds good.
Thank you very much. Right. Eric Welch, ladies and gentlemen. Thank you, Eric. Okay, you may have noticed there's a tail rotor behind me. So tail rotors are, if I had to qualify the two biggest threats that I think helicopters face in general, one is the environmental aspect, and the other one is noise. And so being able to develop a quiet tail rotor is absolutely critical to practical day-to-day operations for all of you guys that want to keep your helicopters at home. The less nuisance we can make to people, the better. And that was really the primary thinking behind designing HX50 with a ducted fan tail rotor configuration. And there's much more to designing a tail rotor than just the noise. The performance is very important, and I've shared over the last month or so that the tail rotor configuration we have at the moment has outstanding performance, all the way up to max gross weight on a 10,000 on an ISO plus 15 day at 10,000 feet. You'll still have full controllability all the way up to about 35 knots from any direction. So this is a profoundly powerful tail rotor system. And of course, if you want a lot of tail rotor authority, you have to put a lot of power through the tail rotor to drive it. And so one of the things that the guys have been focusing on recently is the detailed development of our little tail rotor gearbox that you can see over here. So as you can see, it's fairly conventional in terms of its general arrangement. We've got an exaggerated belt crank for today, just so that you can change the pitch on the blades. But the tail rotor gearbox is coming along very nicely. So Craig, do you want to just come and join me for a second? Craig Jones, ladies and gentlemen, is our lead mechanical engineer. He's been leading the design of the main rotor transmission, the drivetrain in general, and a lot of the work on the engine. So Craig, tell me what we've got inside this gearbox, because I can't see inside there at the moment.
Okay, so what we have in here is a pair of spiral bevel gears, a 90-degree spiral bevel gear set. Using spiral bevel gears allows us to get a nice power to weight ratio on the gear set. It gives us a nice efficient gear set and a quiet operation. Spiral bevel gears are used traditionally for these applications.
Smashing. And in terms of the casings and things like that, how are we making those?
So these will be an aluminium casting, sort of high grade aerospace aluminium 357 casting, heat treated. These prototype gears are made from solid bar for demonstration purposes, but we can learn a lot from these parts.
Fantastic. Okay. And in terms of this gearbox, in terms of the couplings and the drivetrains, is there anything unconventional about this? Have we invented anything wacky while we've been doing this?
No, that's quite the opposite of what we're trying to do. Really, we're not trying to reinvent the wheel. We're trying to take the best of what's out there at the minute and make the best of the latest materials, latest processes, just to do things as efficiently as we can. And that's true of the entire drivetrain, right the way through to the engine, the rotor head.
Smashing. Okay. Thank you very much. That's great. Craig Jones, ladies and gentlemen.
Thank you.
I think the other point I'd like to make about the tail rotor, and I put it out on the app while we were sharing some photos of what we've been doing, is it gives you a sense of scale of the whole helicopter. This is sitting in a little bit low on the stand so that you can get at it to use it. But I think the other thing that's important to come and touch and feel and have a go when we're finished a little bit later is this is the first component where you've seen real evidence of the level of surfacing refinement that's gone into this aircraft. You've all seen the glossy renders, and people have lots to say about those. But what you can see here is where the real fusion between automotive and aerospace workflows is starting to pay dividends. In order to get the light to flow off this so that it looks like a high quality piece of equipment, we need a much higher level of surface design than you would normally use in conventional engineering. And we've got Henry, our chief designer, he's hidden somewhere, there he is, Henry, our chief designer, to thank for delivering not only a strikingly beautiful aircraft, but one that works aerodynamically very well as well. So, Henry, thank you very much. Okay. So, this whole business has been built on the recognition of what we can achieve if we work together. This symbiotic relationship that we've created by understanding what the community wants, listening to the community, and then focusing on the people that really are the light helicopter industry, and that is private owners. HX50 was always about delivering a machine that was from root to branch, from tip to toe, all about the needs of private owners, how they fly, what the machine needed to be to keep them safe, how they experience the cost of ownership of a helicopter. So not the hourly rate, the big fixed bills that you've got to control. That's exactly what this whole business is based on. And so because of that, we've managed to bring a group of people together that have enabled us to grow incredibly fast, far faster than I ever imagined we would, far faster than these guys ever imagined we would. And as a result of that, as a thank you, what we'd like to do is offer a very special opportunity for those of you that were in on day one, supported us with the HX50 program, to share in the benefits of what will come in the future. So in the future, we'll be going out to market with HC50. And HC50 is a commercial aircraft. We've designed a brilliant helicopter for private owners, but because it's so good, it'll make a good commercial helicopter in the future too. And so we have a very special opportunity for those of you that would like to benefit from that. So over the course of the last year or so, many people have reached out and asked if there would be an opportunity to own an additional aircraft, a HC50, or to speculate when HX50 comes to market. Now, we are not going to release HX50 to the general public for around 6 to 12 months. And so in the time period before then, we're giving a limited time offer for those that have chosen to support us with HX50 to benefit from what we're going to do in the commercial helicopter industry as well. And what that is essentially a pre-sales program where for those of you that already own HX50s, if you want to, you have the opportunity to secure a £200,000 discount on the initial list price of £725,000 with just a £50,000 deposit. And that's really, as for those of you that want to, it's an opportunity to share in the benefits that we've created, revolutionizing the general aviation industry. So thank you very much. There we go.
All right, so great. Thank you, Jason. And now, as usual, we're going to be having the Q&A session. So I want to make sure that all the questions are answered. First from the audience, we have a lot from online.
Yes.
By the way, we have just reached 763 people watching online.
Amazing.
So that's a great, great number worldwide.
Yeah.
Thank you very much for supporting us as well. And we have a lot of questions again from online, but we want to give first opportunity for anybody here present with us today to raise your questions. So please go ahead. We have some mics on the floor there. And who wants to have the first
while we're
question?
getting organized, the ladies are going to be bringing a mic for you guys. Just raise your hand nice and high so that they can come to you and ask the question. While the first person's putting their hand up and getting their question ready, Jace, we have one that came in and somebody was asking, can you describe a little bit about how the blade fold kit is going to actually work? So we've talked a little bit about it in the past, but I just want a little bit of an idea. So if somebody has landed the helicopter and they're ready to roll it in the hangar, can you just describe a little bit about what that workflow will look like to get that thing folded up and put in the hangar?
Yeah, no problem. So the original concept for the blade fold was that it would be just a case of popping out the lag dampers. But we're in the process of changing the rotor hub design at the moment to accommodate our elastomeric bearings, our in-house elastomeric bearings. And what that now means is there will need to be essentially a link in the root of the blade outside of the cowling. So you won't need to mess with the cowling on the top anymore. It's a simple quick release mechanism that allows the root of the blade to fold. So that's something that's due to be developed further in the new year.
Perfect. So basically, they would open up the top cowling.
No, you don't need to do that anymore. It'll all be outside of the top cowling.
Okay.
So you'd remove the engine inspection cover, climb onto the top of the helicopter to get access. You'd have parked the helicopter with the fixed blade over the tail, and then you'll just be able to swing the two remaining blades round. So the engine can't be started with the mechanism deployed, obviously, and it's very obvious from ground inspection that it's either open or it's closed. It can't ever be in between.
Okay. So 5 minutes or less probably for the whole process.
Yeah, it's very quick and easy.
Okay, awesome.
Thank you.
Let's go with the first question right over here.
Hi.
Go ahead.
Hi, Steve Brooks.
Hi, Steve.
Hi, Steve.
Steve
It's
Brooks,
good to see you. Yes, Steve Brooks, everybody.
First of all, congratulations for you three. I think if anyone had said you were going to sell 342 helicopters a year ago, they'd have said you were nuts. So well done, guys.
Thank you.
A question, modern flying, it's fantastic in the cockpit, having mobile data, knowing what the weather's doing, having real-time METARs and things coming through. If you're going away from the iPad, is there going to be mobile data fitted to the hardwired to the cockpit? Are we going to have a SIM card in there, or how would that work?
Absolutely. So we're not necessarily going away from the iPad. The system is still designed so that you can have your iPad there and you can have it in front of the screen. So one of the setups for the screens is pilot side gauges, as we've shown, either second set of gauges on the passenger side or the infotainment stuff. And then you can just have the synthetic vision as a consistent background so it looks nice and tidy. So you put your iPad where it was always intended to be. Within that, if you're using an app that can pull down that data, and that's within the application that you want to fly with, then the infotainment box, as we call it, has a 4G, 5G connect card in it. So it has all of that functionality built into the device that drives the apps on the unit. So you won't lose anything.
Okay. Right. Wonderful.
Second question.
Right here. Charlie.
I live in Scotland, and one of the big problems there is the range of helicopters and getting fuel. And trying to go to Orkney from my base, we need to sometimes logistically, well, certainly in a commercial job, we would need to locate fuel by road, which is a real problem. So what do you reckon the range is? What's your best forecast on range, say, half full with passengers and luggage? And will there be an option for a range extender on this huge luggage compartment that you've got?
Okay, so with the, if we assume that the cruise speed isn't going to increase from 140 knots, then if you were to put 5 95 kilo passengers in the aircraft, you'd have enough range for 3 hours of fuel at maximum continuous power. So that would give you 420 nautical miles. But that's if you're flying as fast as you want to. If you back that off, you'll get to 500 or so, and that's with a full helicopter. So that's with 5 big guys, a handful of bags, and so on. If you choose to fill the fuel tank up, it's designed with a 5-hour fuel tank. So again, that's 5 hours at maximum continuous power. And so, of course, 5 hours at
700 nautical miles.
It's been a long day. 700 nautical miles will get you there. But of course, remember, that's at maximum continuous power. If you back that off, you'll go further. So it has a really profound range. It should. No, all of the fuel is housed in the primary fuel tank. The trimmer tank is really just about giving you as close to carefree center of gravity characteristics as you can have. When you make a helicopter with a very high useful mass fraction, so lots of payload compared to its empty weight, the CG problem gets difficult. When you then make a relatively big helicopter for its weight, that all gets worse again, because now you've moved all the variables further away from the mast. And so we have to work very hard to make sure we can keep the longitudinal CG within trim limits. Thank you, Charlie.
We have a question from the back of the room over there. Go ahead.
Hey, hey Jace, Stuart Adams here.
Hey, Stuart.
Hey. Great to be here. I'm not having a cup of tea in the morning watching this on my iPhone. I'm here in person, so it's fantastic. I've asked this question before, and I'll ask it again. The float system. Have you done any more work on the float system, where it's going to be on the aircraft, and also the emergency exits, should we ever need to use the float system?
Sorry, Stuart. Could you
that's the emergency flotation system
the flotation
for flying
system.
offshore.
No, so no, it's a simple answer. We haven't taken that any further yet. We've been very preoccupied with the engine at the moment, so there's a lot of resources going into both the production process development and the detailed development of the engine components. So floats will follow very soon, because obviously our strategy for floats is that we're creating pockets in that composite fuselage you can see over there. So to be able to take the fuselage through to full scale, we've got to do all of that. So it's going to be handled very shortly, but we haven't done anything about it yet.
Okay, thanks.
Okay, we have one from Chris over here. Go ahead.
In that light, Jason, since the integrity of the hull in this one is so good, will it act as almost as a boat when you have to ditch this? Because it seems like you could almost make a case for turning it into a boat if you had to ditch it, right?
Yeah. Yeah.
You're going to get into the boat industry as well?
Yeah. Well, one thing at a time.
Yeah, my current helicopter does not float very well. You know, the doors, let's say, are about as leaky as they can get. So I'm just wondering if
sadly, it won't float. It's not neutrally buoyant. One of the things that I really wanted to do with this was try and find a way if we could have some permanent watertight pockets within the fuselage. But sadly, there just isn't enough unused volume in places that you'd want to use it to make that possible. The only way that we could make that possible would be to fill a lot of the cabin up with airbags. And there'd be little point in having a flotation system if the only thing that floated was the top of the tail. So yeah, unfortunately, we've got to put bags on it.
All right, well, we'll keep going. Thanks.
Thanks, Chris.
Okay, next question right up here.
Roy Marfley.
Hello, Roy.
Hi. What is the timescale on the HC50? And if you're an owner of a HX50, can you transfer across at that price?
So it's not a transfer deal. This is just we've been asked by a lot of customers if they could have a HC50 as well, and if we could give them first refusal on early serial numbers. And some people do want to work their machines. Most private owners don't, and that's our focus, but some people do. So the timescale is still as declared when we launched the program. HC50 will lag by around 3 years, so it'll be 2026. And that's purely because the sheer amount of time it's going to take to push the certification program around the world. And I didn't note when I put the initial slide up that we're strictly limiting this opportunity to people that are within UK, US, Canada, Australia, New Zealand, and South Africa, just because those are the areas where we'll have the most direct route through certification. It's likely to be a more predictable timescale through that. Thank you.
By the way, about that, Jason, you forgot something important. And I have to update what you just said, what you were going to say, which is we already have 3 orders for HC50.
Yes.
Right? And in the meantime, we received already 2 other orders, so we are at number 5 already.
Oh,
so
fantastic.
5 seats sold.
There we go.
Amazing.
Well, that's the buffet paid for then.
Yep. And by the way, just to be very clear, the first orders paid, the 1, 2, 3, is BC helicopters. So
yes,
you're going to see.
We're very excited to have them.
Thank you, guys. Congratulations.
It's going to be incredible.
All right, more questions.
Don't be shy. Nobody's made me cry yet.
It's got to be a lot of.
Yeah, there's 2 hands over here.
Yeah, hi. If you're talking about 2026 for the HC50, when do you expect to start delivering the HX50 to customers?
The HX50 is scheduled for delivery summer 2023.
Okay.
There was another question here, right here.
Yes.
Yep.
Hello there. Good evening, Jason. Good evening, gents. Yeah, I agree with Jason. Simon Huggins. Just thinking about like the battery position on the aircraft. Thinking about obviously when the machine's hangared for some time and like triple charging. Is there sort of a socket or something you can triple charge it, or is it quite accessible? Do you think?
Yeah, we haven't set the position of that yet, but it is designed to be ground chargeable, and we'll provide instructions on that once we've defined them. Basically, the battery chemistry that we're looking at using is quite sensitive, and we have to be careful about how we handle that. So you'll have to let us just work that through at the moment.
Okay, thank you. Also, just obviously with the finish on tail, 3-bladed rotor, like start-up and shutdown limitations for surface wind. For example, on the EC120, it's sort of 55 knots. Would you know at this stage what that might be, or?
I expect something similar to that. It's a very, very similar blade geometry. It's a very, very similar, the fundamental parameters of the rotor have got very similar geometry, so it won't be that different.
Okay, thank you.
And with all of those things, those are things that really are just determined during test.
Sure,
So we won't be able to give you a final answer till it's sat out there.
No, of course, yeah. Okay, thank you.
Thank you very much.
Thank you.
Good, and while we're getting our next question, we had another one come in. We had actually very many come in online, but one person asking about what do you think about the eVTOL situation right now, and is that competition for the HX50, or how do you view that?
So I get asked this a lot, as you can imagine. eVTOL is important. You know, we do need to decarbonize aviation. We do need to become more electric, but you've got to be realistic. The only way to get off the ground vertically more efficiently than a helicopter is in a balloon. So I think a lot of these fancy configurations that people are trying are all well and good, but I don't believe they offer any material advantages over that of a well-designed modern helicopter. And the big elephant in the room that everybody is ignoring is the fact that it's going to be a very, very long time. It's going to be decades before we have batteries or a means of storing enough electrical energy for a genuinely battery electric aircraft to be practical. And I think when the real world factors of developing a machine and operating a machine start to take hold on an already limited capability, then those machines are going to find it very hard to make a living. And so I don't really see that being as an immediate threat for us. I think that many of those companies will struggle when they try and hit commercial viability, when they try and operate real air services. I mean, many of you will have leased helicopters back and tried to operate helicopters commercially over the years. And you know, trying to make money out of an existing general aviation aircraft is very difficult, you know. To have the work and the machine available and fly enough hours to offset your enormous fixed costs is difficult. And then if you try and do that with a machine that can only fly for 5 minutes, you have precious little chance. So I think in terms of eVTOL, it's not a threat, but I think in terms of the opportunity that it provides for us, it's clearly showing how many people want to do point-to-point travel. And that is an opportunity for HC50. That's an opportunity for a good commercial helicopter. I think the other big important point about eVTOL is with the huge swathes of money that have been thrown at it, they've been spending money like it's going out of fashion, and in order to manage their risk, they're trying to partner with all of the same people that we're trying to cut out to deliver a cost-effective helicopter. So they're replacing their expensive turbine engines with batteries that are now owned by, with motors that are now owned by the same people that used to make the turbine engines. So from my point of view, I think those aircraft are going to end up being every bit or more expensive than a conventional turbine aircraft, but far less mission flexible, far less capable. And so, yeah, I don't think that's an immediate threat for us. I think the helicopter has a very bright future. The GT50 engine has been designed to run on sustainable aviation fuel, biofuels, and I think that's our route to short-term carbon neutrality. And I think that's the way it's all going to go. I am very interested in hybridization. I think that's something that could offer a great suite of benefits to private owners and commercial operators. And so you can expect to hear more about that from us in the future, but it's not going to be a battery-powered helicopter for a very long time.
Okay, thank you.
I have a question from Dave there.
Yes. Yep, go ahead and start talking. It'll come on.
Yeah, okay. Oh, it does. Okay, yeah, David, I've got chassis number 199, and we're operating it as a syndicate. So I've got a bit of a boring practical question with regards to the warranty. Could you sort of illustrate how that would work? Because, of course, there's going to be some sort of liability there for the syndicate, and I just want to make sure I've sort of covered how that would work. Could you illustrate a work example of a warranty situation and the features and benefits of that?
Well, I don't think it's a problem, is it? Because if you've got a syndicate, typically they would be that you'd be operating as a limited company or something like that. So the limited company has the same status in law as a person, and so the warranty would apply to the limited company that owned the helicopter. So it makes very little difference. I think
it was more literally the practical side on the ground. Supposing that we need to bring the aircraft back to the factory, and what have you.
I think that's a matter for the syndicate, isn't it? It's not really an issue that we can speak to.
Okay, cool. Yeah, that's fine. Thank you.
Okay, thank you.
Thank you.
And then we have another question just over here as well.
Yeah. Hi, Jason.
I had a question on the control. I think you call that haptic or haptic. Sorry for my English.
Yeah.
As a pilot, what is that going to bring to us? Can you give us a few ideas of situations in which the flying will be enhanced by this feedback from the controls?
Yeah. Okay. So in terms of the haptic feedback, perhaps the easiest one to explain is fundamentally the haptic feedback on the collective. So if you think of the situations in flight where you would want to know what your power situation is, but without necessarily having to have heads down in the cockpit, then what we've done is we've coupled the actuator that sits on the collective as part of the autopilot system, so that as you approach your 100% limit, the collective will start to become stiffer. It will take more effort to move it, and you'll feel a notch when you get to 100%. So if you're coming into a confined area and you're hot, high and heavy, then rather than being eyes down, eyes up, eyes down, you can just feel until you get to 100%. And you know that you've then got another 10% to go. 10% is enough to do a very sprightly vertical climb to get yourself in. So you'll have situational awareness of your power just by what you can feel in your hand. So it avoids what you used to have to do, looking at 3 gauges in a turbine helicopter just to assess if you were going to damage something, and you can feel it. Now, in terms of other areas of flight, then under normal circumstances, you would always want a linear force gradient about the set point of the control. So once you've got the aircraft trimmed, you'd always want it to get harder and harder to push the control further away from you. That's one of the requirements for handling qualities in instrument certified aircraft, for example. So about your set point, you'd always have a nice, gentle, linear force response away from where you are. And then when you get into more critical areas of the flight regime, so perhaps exceeding VNE, or when you've got a dangerous combination of rate of descent and speed, you can expect things like stick shakers. At VNE, you can expect the cyclic to start to push back against you, and then there's a number of ways that we can deal with the others. But what I would say about all of those things is, I'm sure many of you have got nice cars where you get haptic feedback through the steering wheel if you're starting to depart from a lane. And what we've got to be very careful to do is not to just create a response that you're just going to naturally want to fight against. And so a lot of these things will be honed and developed and trialed in flight test. Once you've got the actuators there and you've got the hardware to drive them, you can program that to be anything you want, really. So we have a lot of flexibility about the kind of response that we give and where we want it to give the response across the operational envelope. But essentially, that's the long and short of it. About a normal set point, expect a linear force gradient, and then when you're approaching a limit, expect it to push back harder and perhaps shake to indicate that you're doing something wrong. Good. Thank you, Nicholas.
Another question over here.
Yeah. Hi, Mike Shaw.
Hi, Mike.
Hi, Jace.
There you are.
Many years ago, I was a glider pilot. I know that's perhaps a bit of a dirty word in here, but it was quite good fun flying without an engine. But I used to fly in the Scottish mountains quite a bit, and used to experience rotor turbulence, going up through rotor into wave formations, wave clouds and so on. And when I became a helicopter pilot, I sort of felt slightly terrified that one day I might come anywhere near rotor turbulence, because you feel in a glider that like you're going to have your wings broken off. And I've heard stories of people who've died in helicopters when they've got into unintended rotor turbulence. And I was reminded of it when I watched one of Mischa's recent videos where he was bringing back a squirrel, I think it was, and saying it's the best helicopter available at the moment. And I did smile, because I knew what probably was in his mind when he wrote that, and saying how smooth it was in turbulence. And I thought it'd be really interesting to get your spin on how you think the HX50 will operate in turbulent conditions. Obviously, it's a 3-bladed system, which is, big head start.
Yeah. So I think that there's a number of things that contribute to how the helicopter will ride. The big one is really that the moment you go beyond 2 blades, the moment you've got that 3rd blade and your flapping hinge is offset from the axis of rotation of the rotor. That gives you an inherent stiffness between the rotor and the fuselage. And then that means that any time the aircraft is hit by a gust, a side load, it's going to want to stay where it is. It's going to want to stay in its commanded orientation directly underneath the main rotor. And then the other thing that you've got going for you, of course, is if you have a higher inertia rotor system, that thing wants to act like a big gyro in the sky. So it just wants to hold its orientation in space. And those two factors will contribute significantly to making the thing feel very stable. You'll never feel that sort of disconnected sense that you can get in machines that have two blades, where you are just being moved around and you're only really being held there by your weight pulling you down from the rotor. So it'll ride a lot better. I think the other thing to be aware of is because we're aiming for the machine to have great cruise performance, we've got a very big horizontal stabilizer. So that's designed to keep the fuselage very flat in flight. Now, when you're flying slower and when your experience is experiencing updrafts and downdrafts, that will create a bit of a pitch response that you'll get used to. And of course, we've got a very big tail fin as well, and that's there to keep you safe in the event of a tail rotor failure and to look after a number of other things as well. So it'll feel very, very planted, very stable. It is a big, heavy helicopter after all.
Lots of reassuring stuff, thanks.
Thanks, Mike.
That's music to the ears, because flying lighter two-bladed helicopters in the mountains in turbulence is not really that fun. So I definitely appreciate that.
Jason, we have a question from our good friend Carl, who's watching online.
Hi, Carl.
So he's asking about what are your thoughts on hydrogen cells? Some VTOL aircraft have announced they're going to be working on that or working. What are your thoughts on that? Hydrogen.
I don't believe that will work either. So I can't say who it was for, but I did some work many years ago for an organization that was looking to put a fuel cell in a similar size aircraft to HX50. And the fuel cell technology is amazing. That's been ready since the Apollo programs. You know, that is great. The electric motor technology is great, but the problem with hydrogen is it has a really, really low density. So jet fuel is about 800 kilos per meter cubed. Hydrogen is 72 kilos as a liquid per meter cubed. So what that means is, because the amount of energy in a fuel is defined per unit mass, if it's got a low density, you need a huge volume of it. And so to carry enough hydrogen to have the kind of range that we're offering with HX50, you'd have to more than fill the entire cabin with hydrogen to have enough of it with you to power the engine. So until somebody can find a way of storing hydrogen other than as a diatomic molecule, we're not going to be able to make that work. I don't believe. I think it's another way of clawing at the idea of being able to get rid of fossil fuels. I mean, we already have a very good way of storing hydrogen. We stick it to carbon molecules and create hydrocarbons. So it's not an answer to the current problem, but it's not an easy problem to solve, I'm afraid. For the time being, my genuine belief is that sustainable aviation fuels are a practical way to do it in the short term while we wait for some form of storing electricity or packaging hydrogen. But I think it needs a step change in technology. It's a cassette to CD moment that we need, not a we'll just squeeze it in a bit harder. It won't work, I'm afraid.
And what's your confidence level on GT50 running on biodiesel?
Oh, that'll work. It's just another fuel. Yeah. So these industrial engines are designed to run on all sorts of stuff. So you need to make some modifications in the FADEC system. You need to make some modifications. Well, you need to design your combustion system to run on these fuels. But sustainable aviation fuel is being designed as a drop-in replacement. So we're just taking that into account as part of the combustor design. Yep. So that will work straight out of the box.
Okay. And a question that we get a lot, so it's kind of a two-part question. Are you going to be able to put skis? A lot of people want to use this helicopter for skiing. Are you going to be able to put skis somewhere in the helicopter, in the baggage bay, or somewhere else? And will there be, at some point in the future, a Hill-made pod on the side for skis? Or somewhere on the aircraft for skis?
Yes. Could you put it, Michael, a bit? We have some reports of hearing.
Okay.
Isla.
yes, you will be able to fit all sorts of things in the helicopter. So as you're well aware, all of the seats except the pilot seat are removable. So for really big stuff, you could get that in the cabin if you move some of the seats. The baggage bay is vast, and I think we can get almost up to the biggest size of skis straight into the baggage bay directly. We've just moved some of the bulkheads, so I'm not going to tell you it'll take the 2-meter ones at the moment, but I think it can. And one of the things that we're doing as part of the structural design is there's a provision for all sorts of utility mounts being built into the composites right now. Now, we don't have an application for those at the moment. Yep. We're just providing a structural hard point to be able to add bolt-on equipment later. Right. And yes, when it comes to attaching lifestyle products, people carry their bikes in helicopters, their skis. I've even asked...
Only crazy people in Canada do things like that.
Yeah, well, people have asked me, can I put a motorbike in the back of it? I can't remember where that one came up. But we're making provisions to attach stuff to the underside, and that's really making sure that it's a common fuselage between HC and HX50. Yep. And the same with the baggage bay. There's the seat rails and all sorts of things in there.
Right. And you've mentioned that there's going to be sort of a universal mount that you're creating underneath the aircraft. There's several mounting points where you're going to be able to attach things,
we've specified 9 mounting points that tie in with the existing structural design. They're just designed to take a given load and have a given type of fastener go into them, and you can do what you want with them after that point. Yep. And there are also existing hard points on the exterior of the structure. One of the questions we get asked a lot from the guys that want to marinize the helicopter is, how do you tie it down on the back of a boat? Yes. And so the brackets that mount the undercarriage legs are also used as tie-down points, and so are the points that would, on the skidded version of the aircraft, pick up the forward points of the skids. So you've got 4 points to tie the thing down as part of the standard fuselage design.
Okay, but nobody would ever get the skidded version, right?
Nobody will ever buy skids. You'd have to be crazy to buy skids.
Okay, let's go for another question in the audience. Who has the next question? Yes, right here. We've got a mic coming over to you right now.
Hi, my name is Thomas. When do you hope to have the first full-scale fuselage done?
Well, that's a good question. Sometime next year. Around the middle of next year, I would say.
Okay. Now I have another question. For the engine, will you be able to remotely check parameters?
So yes, to a certain extent. So the stuff that's reported to the pilot in your flight instruments will be reported to us. We'll be able to pull that data back.
But not live? Not us running the engine and you monitoring it?
Potentially live, but again, it's complicated because the only real way that you've got of doing that at the moment is 4G, 5G, and depending on how high you are, you'll lose signal coverage.
No, I meant more, let's say that as an owner, I was not completely sure things were running correctly.
Yeah.
And I wanted to do a ground run on it, and then have somebody remotely be able to just sit with the software and check that things are running within parameters or not.
That will be possible, but there will be a period over which that has to be rolled out. We can't do everything right.
But
from
in
the start.
theory, possible.
Yeah.
Okay. Thanks.
Thank you very much.
Thank you. Next question. Don't be shy, you guys.
We now have
right over here.
By the way, Jason, 1,284 people online.
Wow,
that's a really high number. Very, very great success.
A couple of questions. Jace, I'm over here.
Over here.
There you are.
Yes.
Is the collective gone back to a traditional collective, or is it still the collective?
Still the same. So we've got 2 different styles of collective. The pilot side is the one that you're used to seeing, and not all of the images showed the collective on the passenger side. On the passenger side, allow me to demonstrate. If we move the collective to a more upright position for the pilot, because rather than doing this, you want to be able to do that, so your elbow slides along the armrest, so it's comfortable. But of course, if you had your collective here on the co-pilot side, you wouldn't be able to get out the door. So what we've had to do is take the same stick head, and it's slightly different geometry, and just return the pivot point back down to a bit further back behind your seat. So on the passenger side or the co-pilot side, it's a more conventional action. It moves by the same amount, it's the same stick head, same controls, but it's slightly different because obviously you don't have the armrest there, you use the window ledge instead.
Okay, and I'm not going to hold you to this, but when do you think we'll see the first flying HX50, and are you still on track for summer 23?
As we stand here today, we're still on track, and the plan is for the first prototype to be built by the end of next year. So we'll fly it as soon as we've proved that it works properly on the ground.
Brilliant. Thank you.
Thanks, Charlie.
You know why he asked this first question, right? Because when you were doing your demonstrations earlier about the power management, you were doing this motion.
Yeah.
It's a little bit too ingrained.
Muscle memory.
Yeah, All right, next question. Right here, Charlie.
Charlie.
Mike's coming to you right now.
Have you got your permission for the factory to go ahead?
We're getting
and the
closer. So
location?
we had some absolutely amazing buy-in from the local government a couple of weeks ago. So all of the people that need to be behind it are now behind it. And in terms of the planning permission for the manufacturing part, it's a no-brainer. The site already has permission for that, and that will go through in a heartbeat. We were trying to get some acoustic surveys done over the last couple of weeks, and we didn't quite manage to get all of the parties involved together all at the same time with the weather for the helicopter and everything. So we've got to pick up those acoustic surveys after Christmas. That is the only challenge. Everything else is just due process. So that will be in place, I would say Q1, early Q2 next year at the latest.
And by tradition, Jason, helicopter manufacturers either buy an airfield or operate from, or manufacture from an airfield. You're going to be different, I understand.
Yeah, well, you know me, I like to be difficult.
No, I said different, not difficult.
Yeah, the problem with airfields is a lot of them are owned by people that want to squeeze every last penny out of them. A lot of them have been bought up by housing developers, and they really don't see any value in keeping it as an airfield. They're just biding their time until they can get planning permission approved to put houses on them. And some of the ones that are good are not really in the best location for us in terms of the wonderful people that I've got working for me at the moment, the supply chain that we have in the area. So we need something fairly close to where we are at the moment. So airfields are challenging. Ideally, that would be a great way to do it, but I don't think that will work. I think the beauty of the approach that we're taking at the moment is that although it creates a challenge in terms of planning permission for noise, if we choose our location carefully, there's such an enormous number of jobs being created that what we're seeing is the politicians and the local councillors are falling over themselves to make it work. They just have these medieval processes that they have to go through to make it so. So I've got no doubt that that'll go through.
But in a practical sense, how do you deal with the safety course and the conversion courses that you're going to be doing at the factory? And then churning out helicopters that fly away and come back for engineering?
Yeah, our site can be approved for all of that.
Excellent. Next question. Yep, Becca. Get you a mic.
Becca came all the way from the US.
Yes.
Yes.
Hello, so my question is for the fuselage guys. So we have this glorious one-piece fuselage. What is the idea, or perhaps the process for, I mean, heaven forbid, if you have damage? Like, is there going to be a way that you can, they can mend it, at home, or will you have to bring in a specialist?
Well, you've got to be realistic with a helicopter fuselage, is that it's not just about repairing it to a point where it's going to stand up to the static loads again. That's got a 50-year life ahead of it where we have to have confidence that it's not going to develop fatigue problems later in life. So within any aircraft, there's only so many components that they will let you repair. And I think it's very common if there's any plastic deformation, for example, in a metal fuselage, that part's scrapped. So there are areas of the fuselage where it will be fairly insensitive to damage. A lot of the stuff that you're likely to knock, for example, your doors, your windows, none of them are structural. It doesn't matter. The key beams that you can see that hold the center doors, for example, which is, I guess, a fairly vulnerable location, is set back behind the door. So you'd have to crush through the doors, the windows, all the mechanisms and things before you got to that. So it's fairly robust in that sense, and it's a fairly tough material anyway. So in the first instance, the degree of repairability is fairly consistent with what you've got in other aircraft, but it is a critical flight structure. So if you damage the stinger, for example, on the bottom of the tail boom, that's a throwaway component. That's there just to be clipped, and that can be swapped out. The rest of the tail boom is structural. If you delaminate it, we'd have to replace that. But remember, these components aren't going to be anywhere near as expensive as what you've used to. So there'll be a degree of repairability, but it'd be what you would expect from a flight critical structure.
Thank you.
You're welcome.
Next question.
Don't be shy, guys.
Yep, back over here again.
It's been covered, I think, on your website and stuff, but could you just remind us of the hours on the engine, in the turbine, the cycles and all that?
Yeah, so the engine's designed to be a 5,000 hour TBO, and we're targeting 20,000 cycles on that.
Okay, nice.
As are the 2 gearboxes, right? In 5,000
Yeah.
hours? Yeah. Good.
Jason, we have another question online from our group, actually, the owners app. On the starter generator, assuming you have a low voltage scenario, due to perhaps the aircraft sitting on top of a mountain for a few nights, does that starter generator just need enough energy to begin to move the shaft, and then it becomes itself addictive to the energy requirements to continue the start? I thought here it does the start the generator by, I thought it does generator, requires the start the generator to buy as benefit when mole of source energy for start. I don't understand this, the last part.
Okay, so no matter what you do, you're going to have a problem with cold batteries, aren't you? You know, so there comes a point where you've just got to keep your battery warm, otherwise the batteries physically don't work. So to a certain extent, the batteries will be self-contained, but there comes a point where you've got to either warm them up or take them away for the night with you. And that's what's borne out in the way that they test aircraft as part of the certification process. So the really cold climates like Canada and whatnot, you can do all sorts of things to protect your battery before you do the cold start test. The starter generator is a starter generator, you know, unless you drift below the temperature range that the fundamental electronic components are designed and qualified down to, it doesn't really care. So I don't anticipate any more problems than you would have with any. Our starter generator system is no more prone than anyone else's, but the physics is the physics. We can't do anything about the battery chemistry.
Low temperature for a long time, no power. Right?
Well, the starter generator will be happy enough, but the battery won't.
Right.
So,
will there be something that doesn't allow it to start if the voltage is too
yes.
low?
Yeah. Yeah.
The FADEC will take care of that, right? The dual FADEC?
You can't hot start this.
Yeah, exactly. Okay. Go ahead.
Another quick question. Will you have any engine programs? If the engine has to go for...
Where are we?
I'm here.
There you are, sorry.
Will there be any engine programs, you know, where you pay by hour or something if your engine needs to go back? And
yeah, there'll be, so you've obviously got a very generous warranty to start with, and then there will be a subscription-based maintenance program as well. So yeah, that will be forthcoming, but you'll have to give me a little time to finish what I'm doing first, and then I'll sort that out for you.
Good. Another person asking online, funny one. Since you're going to have a lot of recycling waste from the milling process, but given that you have casting equipment, a CAD, the system, and models, can you cast some desktop size HX50?
Yeah. Again, yes, we can. And Henry's been mithering me for years now to do a speed form HX50 as a desktop ornament and things, but we've got to finish everything else first. Yeah.
Let's do the flying one first. One step at a time.
Let's do that, then we'll do the executive toys.
Yep. Do you want to just talk while we're waiting for the next question? Don't be shy to raise your hand so we can get the mic over to you and we'll be ready to go. But just talk a little bit about the redundancy. Now that we have the 3-screen application plus the iPad, are those all redundant? So is it technically a quadruple redundancy system? If one fails, you could move to the next one and so on? Because, a lot of people, they ask the question, well, I don't want, all the glass because I want to be able to have some sort of a backup, a steam gauge backup in case, everything goes dead on you. So can you talk a little bit about those redundancies?
I'll come to the redundancies in a second. Absolutely, I can.
Yeah.
But why don't we start by saying, what do you actually need to fly a helicopter?
You don't have to convince me because I just look out the window and I fly the helicopter.
Yeah, we fly helicopters by attitude, and if it's all getting really bad in the air, then it's a helicopter. You can land anywhere you want to. So the idea is you just keep it very simple. If it's all getting too much, land. And our training procedures will cover exactly what's required in each of the failure scenarios. And we're doing some very basic things to allow you to fly the aircraft very simply without all the fancy bells and whistles working. But in terms of redundancy, you've got the Avidyne suite, which is fully certified. There's highest quality certified instrumentation that money can buy. And that feeds out via 2 screens and an app. So both the screens are redundant. They've got independent power, independent drivers, independent touch screens. And then the Avidyne box also communicates wirelessly with your iPad. So you can drive the box from your iPad as well. And so you've got 3 layers of redundancy there. And then on top of that, the display box that we're using, all that does is it receives the information from the Avidyne and presents the lovely cockpit. If the infotainment and that environment doesn't work or falls over, then you have the ability to just switch back to the standard Avidyne interface that has no fancy stuff behind it at all. So you've got all of those layers of redundancy, and of course you're all flying around with iPads. So you've got your airspeed, your altitude, your position, your navigation data on something that's completely independent as well. So, I mean, the levels of redundancy that we've got are far more than is required for a VFR flight.
Yeah.
Just look out the window.
Yeah.
Just look out the window.
Jason, 2 questions from one of our latest clients and Italy, Ferdinando. Hi, Ferdinando. Great to have you online. So 2 questions from him, interesting ones. Be ready for the second one. This one is the easy one, and also the other one is easy, but you understand what the intent of my question. So one is, can you talk about the rotor head details, rigid, semi-rigid, what it is? So cover a little bit of the rotor head. The second one for you be thinking is, what are the plans for delivery capacity of first and second year? We had a conversation about this previously. It's an inside joke, so get ready for that one.
Okay. So in terms of the rotor head, the rotor head is essentially an elastomeric rotor hub. So both the flapping, the lead lag, and the feathering hinges are all handled by these elastomeric bearings, these laminated elastomeric bearings that we've been developing over the last few months with a company called Camberley Rubber down the road from here. So the beauty of these types of heads is they're very, very compact, they're very simple, and most importantly, because the hinge that's delivering all of the blade motion is only loaded in compression, they have fantastically benign failure modes. So as these bearings twist and turn and bend, they create little crumbs around the outside, so you can tell when the bearing's starting to become degraded. You don't wait until you have something catastrophic happen. So that's really nice, and that also works extremely well with our packaging. As you can see, looking at the posters around, we've got a very careful aerodynamic fairing around the rotor hub, and this particular hub design allows us to have the most convenient root treatment of the rotor blade, so that it's essentially rotating around a spherical center, so that we can cowl that and prevent the hub from swallowing lots of air as you fly through the air and creating lots of momentum drag. So that's the rotor hub. It's similar to what you might have found on other helicopters with three-bladed rotors before. So modern, compact, but proven. So that's the plan there.
And can you just maybe touch on the cowling that goes over it, so the casing around it, why you did it, the aerodynamics reason, and also just explain, how, if and how it's going to open and how you can inspect inside of there if you want to do pre-flight inspections and so forth, because I think that's sort of a mystery area where a lot of people don't really understand it. They see it in a picture and they go, well, is that the way it's actually going to look? Or is that just a render?
That cowling is really, really important aerodynamically, because a huge proportion of the drag of a helicopter just comes from the mechanical stuff that holds your blades on the top of the helicopter and the pylon. So hiding those behind a very carefully faired gearbox and mast, and then fairing in the rotor hub, makes a huge difference to the drag. I think if we took that fairing off and took that cap off and just left the gearbox on show, and that would double the drag, maybe more than double the drag of the helicopter. It's huge.
Right.
And so it's very important that's there. In terms of inspection, the cowling itself will be split, so these don't show a split line that runs around the midpoint of that so that the top can come off, so that you can see everything. It's very important that you can see the Speriflex bearings, the lag dampers, and the root end of the blade. So all of that is readily inspectable, and that's just a quick release device. Again, that we haven't done very much about because it's just a fairing at the moment.
Yeah.
So we'll get to that later. So that's straightforward enough. And then in terms of
second question.
The second question, we're in interesting times at the moment because we're selling helicopters a lot faster than we ever expected to. We're selling more than we ever expected to, and that's only going to increase and go faster and faster. And so we are constantly reviewing the target for initial production and the target for ongoing production. The factory that we're developing at the moment is scalable up to 1,000 aircraft per year, and where we pitch in is very much about where the orders lie as we approach the point where we've got to press go. We need a number of months to be able to order the sheer amount of these machines that we're going to need, and the casting infrastructure and all the composite stuff and everything else that we've got to do. We need a reasonable amount of notice, so there will inevitably be a ramp up. But it may well be that if things carry on the way they are at the moment, we revise the production capacity up right from the start. So I'm not going to commit to what that number will be, but it is likely to be higher than what we've talked about so far.
Let's speed it up. Yes.
And in the meantime, we've had a couple more commitments for the C model as well. So that's increasing.
I'll keep talking then.
We have a question over here again. Yes.
Yeah, hi. In the recent storm, one of our animal field... I'm over here, Jason.
Sorry. This light is right in my face. I can't see anything.
In the recent storm, one of our animal field shelters decided it wanted to be a helicopter. And it lifted probably about, 10, 15 feet, and decided to land in the adjacent field about 30 meters away. Managed to land on its skids, which was quite remarkable. But I was left with the problem of thinking, would an HC50, if I had one, or an HX50, be able to lift this field shelter if I had a load hook and put it back where it's supposed to be? So do you have a view as to what the lift capacity would be with a single pilot, say with low fuel, in order to carry a load? And again, inspired by one of Mischa's brother's recent videos on long line lifting.
I think the limit is, what's in the book at the moment? Is it 800 kilos?
But he's saying, yeah.
So it can lift it off the top. I haven't thought of that number for ages. I think it's 800 kilos off the top of my head.
So just under a ton then.
Yeah.
So not too bad.
So you'd have to take a pilot and a bit of fuel off of that. So, yeah.
Okay. It might be a little bit. It might be a little bit more
less.
than that actually, but we'll.
Maybe I'll dismantle into two halves and do it that way.
Yeah.
Right, thanks.
Thanks, Mike.
Our friend Blue that couldn't make it from South Africa.
Yes.
Special mention to him because he really
Hi,
tried
Blue.
online, and he has a technical question. Please ask about compressor flushing. How often would the sand filter have a filter light that will activate when it needs to be cleared?
So 2 questions there. Yeah. Okay, so this is entirely dependent on the specific environment. I think I was talking to Becca not long ago, and she's flying tours at the moment out in Florida, and they're having to wash the compressors every day just to keep the engine working. And of course, we all work with the same materials. You know, these are the same alloys that everybody uses, so we will face the same problems. So if you're operating in a very salty environment, you will need to rinse the compressor frequently, otherwise you will have corrosion problems with that. In terms of the filters, again, that's entirely subjective. If you're in a dusty or demanding environment, then the filter will need cleaning regularly. It's being designed with bypass doors, so that if it does get clogged, it'll open the doors, bypass it, and that'll give you a warning. But unfortunately, there's only so much you can do with filters. And there's only so much you can do with very, very aggressive environments when we're dealing with components that are by their very nature extremely highly strung. You know, we didn't talk a lot about it, but these compressors, just to get the performance, have to spin so fast that the margin against their yield strength is very, very small. And you can't make them any stronger because all the loads come from the fact that there's mass there. So these are very highly strung, thoroughbred components. So there's only so much you can do with that. We have to be realistic. And I think the second question on that as well was how often you'd need to change the filter in sandy conditions, dusty, sandy conditions.
We're really not in a position to answer that at the moment. We'd have to do some trials on that. I'd expect it to be the same as everybody else because the filters are basically the same as what everybody else uses. So don't expect any surprises.
And we have a question from Andrew Jackson from Waterloo, Ontario. And it's a question we've had in the past, but it's a good one to address maybe, is especially when we're talking now about things like the 4G, 5G connection and so forth. What about cybersecurity with everything that's on board the aircraft? So talking about the different systems, I think the question is more coming from, is there a risk of having the aircraft being controlled externally while you're flying it?
No, all of the stuff that's connected is just passive stuff that monitors. The things like the FADEC control, which is obviously super critical, and also flight control computer and things like that, they're not connected to that in that way. So no, they'll be isolated. They'll be sandboxed from that.
Autopilot, same thing.
Yeah.
Okay.
So no, I don't anticipate that being a problem.
Excellent.
Chris.
Yes.
Jason, unless I haven't been paying attention or listening, could you speak a little bit about the rotor design and the manufacturing process? Will that also be done in-house, the rotor blades?
Yeah, so the rotor blades are composite. They're intended to be composite. I think we've got 2 choices with this. The conventional way of making composite blades is with prepreg, and I think we'll probably almost certainly end up that way, making blades in much the same way as other manufacturers that I've been involved with in the past make them. And I think it's one area where precision is absolutely everything, control of the fiber orientation is absolutely everything, and fundamentally, you don't need a lot of material to go in a rotor blade. So even if the materials are expensive, even if the tools are expensive, and even if you need autoclaves, they're small ones. So I think it'll be an entirely conventional way of making the blade. So you'll have a carbon fiber blade, almost certainly a foam core, and then a metallic erosion shield all the way around the leading edge to give you the durability against rain and dust and insects and particulates out there in the atmosphere. So that's a very conventional process, and again, that will all be done by us. The metal shield, erosion shield on the front will almost certainly be electro-deposited. So it'll be an electro process that we use to form that.
Thank you.
You're welcome.
Excellent. We got another question over here. There's actually 2, so start over here. Oh, I've got the mic already here, so go ahead. Yeah.
I got the mic. I'm in charge. Yeah. Jason, I'm in your 1 o'clock, coming out of the sun at you. So there's something you've been teasing us with for ages now. You keep saying 140 knots, but maybe, perhaps if. So come on, how fast is it really, really, really going to fly? You can tell. There's only
It's going to fly at 140 knots.
We're all friends. We can turn the guys online off for a few minutes if you like. Come on, how fast are we going to go?
Jace, we're all friends. Come on.
Yeah, come on, Jace.
I'm not being
It's
drawn.
140
I'm
knots,
not
Jace.
being drawn on that.
141?
Oh, boo.
So it's
It's what's in the purchase agreement, right?
Yes.
yeah,
Exactly.
Yeah, it does exactly what it says on the tin, Mike. So,
Henry's done a very good job at making it slippery.
Since we had our little sit down, we've done a lot more work on drag, and so the drag is actually lower than we've accounted for in any of the performance calculations.
So roughly what percentage lower is the drag, Jace?
It's a tiny bit, just a tiny bit.
About a third lower than I thought it was.
Does that mean a third faster, Jace?
No, sadly it doesn't.
We'll get there eventually one way or another.
Yeah.
If you're going
when
downhill,
I've
you might
taken
get
this up, I'll tell you
141
how
knots.
fast it goes. At the moment, there's a lot of different ways of thinking about the speed. So the cruise speed that we're quoting is how fast it will go at max continuous power. And that's very conservatively estimated at the moment. Unless we make a terrible job of manufacturing it, unless we mismanage all of the airflows through the engine bay and make a right mess of the rotor head, it will exceed that by a lot. And to set some perspective, this won't be a cruise speed, but for a little publicity stunt, I think we will almost certainly be able to take the speed record set by Gazelle and break that. But that won't be cruise speed, and you won't be allowed to do that.
But it's just, you know what? It's just between friends. Nobody's watching us right now.
Yeah.
So the rest is watching us. Forget what we said, right?
Yeah.
What we just said.
Yeah.
They already hammer us sufficiently saying that, how is 140 possible, right? So let's keep it 140.
Yeah, it's just 140. Just downplay it.
You don't want it to be
Nice,
too
all right.
fast, right? The time will go by too fast.
Yeah,
you need to enjoy the flight.
Again, the whole question of how is 140 possible? Well, there was a study done. Many of you that have seen some of these things before will hear me say this a lot, but there was a study done by the Army on the Huey. The Huey was designed as a utility helicopter. It's all about being able to pick stuff up, and they paid scant regard to the forward flight performance because it was always about getting into landing zones and lifting stuff up and taking it away and dropping gunners in places. And they eventually decided that they'd like it to go a bit quicker. And to do this, all they did was put a very crude cowling, just a Naka series aerofoil around the mast to get rid of that ludicrous big mast that they have on the Huey. They did some little fairings around the blade cuffs. They got rid of the balance bar. They put some teardrop fairings around the blades, and they put a really funny-looking aerodynamic cowling on the back of the fuselage. That put 30 knots on the Huey. So at that point, the Huey was cruising at 140 knots in 1959. So it's not that there's some fundamental aerodynamic limit that stops this from happening. The aerodynamics don't really get complicated until you get up 170, 180 knots. But to get to that speed, you just need loads of power or a very, very slippery helicopter. So we've made you a very, very slippery helicopter and giving you loads of power. That's why it does 140 knots and a bit.
We have another question online. Just put it in one. The rest a lot now. Let's try to manage this. Okay, since this is a single engine helicopter and you showed us a lot of interesting features, do you have any plans on integration of rotor kinetic energy keeper in case of engine failure? Kind of an electric motor hybrid, which will provide a little more time for a pilot to react on the collective.
No.
No. Next question.
How about we have a system that supports auto-rotation with the autopilot that we're already carrying? So what's the biggest store of energy that you've got in forward flight, particularly if you're whacking along at 140 knots? It's the amount of kinetic energy you carry in your forward speed. So just the tiniest cyclic flare will give you tens of seconds at that sort of speed if you do it right and you react immediately. So there are other ways that you can achieve the same thing. And that for us, there's a more intelligent way of doing it. I think you don't want to do anything that adds complexity to the helicopter. You don't want extra motors on the gearbox. You don't want anything in that gearbox that can create a failure mode that can stop the gearbox, because that's curtains then for everybody. So in my opinion, there are better ways of doing that. I think, and I also think that one of the things that we all need to do as helicopter sort of owner operators is be current and be on top of your game. And I think if you're worrying about the time to react in a helicopter that's got as much inertia as this one has, then you're just not current. You know, you're just not training enough. You're just not comfortable enough with auto rotation. So I think it's a distraction. It's not the right way of doing it. Have a great helicopter, fly it all the time, train with great instructors, and the inertia that you've got in some of the bigger helicopters, the Jet Ranger, the Squirrel, and things like that is more than enough.
We have a question coming from over there in just a second. We've got Michael Thompson as well asking, and this is an easy question. I think it'll be a quick one. If you were just configuring your own helicopter, would you choose skids or wheels?
Wheels. Wheels.
That's a no-brainer.
And then I'm probably going to have Becker's Airwolf paint scheme as well.
Yeah.
That actually was the same question from the syndicate in New Zealand, so that's one is solved already.
Yes.
2 in 1.
Yes. Go ahead.
Jace, it's Stuart here again.
Yeah, over in the corner.
At some stage, I do live in Canada, but I want to send it down to Australia so I can fly it around Australia. But shipping it in sea containers, I bought a vehicle up from Australia to Canada a couple of years ago, and we had to degas air conditioners and get a lot of preparation done to go in a sea can. Have you done any more thinking on how to prepare the aircraft for shipping in sea cans? And other things could be the dampeners on the wheels being affected by constant movement over a month sitting in a sea can on a ship perhaps. Has any thought been gone into preparing the aircraft for shipping in sea cans?
Yes and no. So we periodically check that as things have changed with the geometry and the way that we connect major elements of the fuselage, that everything still fits the way it was intended to when we set out. So breaking the thing down, getting it off its undercarriage, getting it into a container, the different degrees of breakdown that are required to get it into different sizes of shipping vessels is checked periodically. But in terms of the absolute nuts and bolts of it, no. We won't really go back to that until we finish solving the big issues.
Yeah, I think the degassing of the air conditioner is a bit of an issue. Because you got to regas it when you get it back out, and that's specialist equipment to do that, of course.
Yeah. Okay. Well, we'll bear that in mind. We'll bear that in mind, and we'll have a look at that. Thank you,
Charlie.
How will the Jason, me again, I'm afraid. How will the HS50 differ from the HC50? Or how will the HC50 differ?
It won't. It won't. Like we said right from the get-go, they're identical. They're identical aircraft. They're both Part 27 aircraft with a EASA CSE or Part 33 if you're in the US engine. So there is no material difference. The only difference that I indicated for HC50 is that depending on how we get on with a couple of the ways that we're presenting the avionics for approval, there might be some differences in the way we display the flight information on the flight displays, but we believe we have a solution for that at the moment. If that's the case, there'll be no difference.
A sensitive question then follows that, which is how can you justify a 160% increase in the price over the HS50?
Because it's a working machine. You know, it's an asset from which people are able to derive a commercial reward. And there's also a much higher degree of liability carried by us with a commercial machine in terms of the product liability that's carried with those. So there's an uplift to cover those costs and exposures as well.
I would like to order one if you put me down for it, guys.
Excellent. You're number
Thank
12.
you, Charlie.
Nice.
Yes.
One question there.
Right there.
Yeah, put me down for one as well.
Nice. You like number 13? No problem with number 13?
I'd like number 5.
We're in 13 already. That's great. You have it. So,
thank you.
Any more? I have a question here from the. Now, this one is interesting, but all questions are possible, as we always say, right?
Yeah.
So, I believe I saw on your Instagram, you expect to have an aircraft flying by the end of 2022. And you also stated that. How can this be the case if the full-scale fuselage will not be completed until middle of next year? So how is this possible? Fuselage in middle of the year and then flying end of the year?
We've got an awful lot of things going on in parallel at the moment. So the way these engineering programs work is there's a lot of stuff that has to be sorted out. There's a lot of things that have to be done in parallel, and at the same time you're building the business and you're building the team that deliver this. So it's not a linear progression. You can't expect it to just be the same pace all the time. We're rapidly growing our team. We're rapidly growing the amount of things that we're doing in parallel. And as you've seen, I mean, if you've seen the journey that we've been on in this year alone, we've gone from a small office 100 meters up the road to this place with in-house manufacturing and a massive team working across the program. And that will continue to accelerate. So don't expect this to be a linear progression. Yeah, but at the same time, you have to be rational. You know, we've got all of these things going on in parallel. There's an awful amount of technical challenges and risks to manage as we go through the program. So we can only deal with those as we uncover them and face them. But as we stand at the moment, the roadmap we're laying out is for that aircraft to be built at the end of the year. And as soon as it's done, its ground runs, we commence the flight test program.
Excellent. Good, next question.
Any change? Oh, sorry, I was just
Go ahead.
filling in.
Yeah.
Go ahead.
Yes.
Have there been any reactions from the industry, other helicopter manufacturers, anybody reaching out to invest or anything?
There have been a couple of people interested in the engine in particular. But other than that, no, we've been left alone at the moment. I think they're just waiting and seeing what's going to happen.
They're probably watching today.
Yeah, I would imagine so. Hi, boys.
We had another question from a good friend in the U.S., and he's asking how long will the offer? I think it was a little bit quick there on the screen. How long will the offer for the HC50 be open for the HX50 owners?
It's strictly until the end of January. So
it's
January
not
31st.
number-based, it's time-based.
Yeah.
Just giving an appropriate amount of time for these people to
Yeah.
deal with it. Yeah, okay.
So
Is any change on the build time for the owners?
no, like I said to you, my ambition for that is to get the core build time down as low as possible so that we can make the program as flexible for people, and it gives us the ability to adapt it then for syndicated ownership, joint ownership, people that want more people to be involved in it, just so that we can then focus on the educational side of it, so we can do the flight training, the maintenance training, and people can have the biggest exposure to all of this sort of stuff that we can possibly give within a time period that they can afford to be away from their businesses.
Yeah. Ed?
In regard to the countries that you're going to be certifying the HC50, in Kenya, my understanding is as long as it's certified in the US, you can get it certified, or it can fly in Kenya, for example.
Yeah, that's absolutely true. There are two ways that you certify an aircraft. Some countries require essentially a full parallel certification program where you have to go and compliance show for everything across the whole platform as if it had never been touched before. And then there are other territories around the world where it's just a type acceptance procedure. They accept the authority and competence of foreign authorities, and they'll just sign the aircraft off as good to go. In those territories, then it's fine, we'd accept it. The ones we've gone for are the territories where they're simultaneously big chunks of the global helicopter market and have practical authorities that are straightforward to work with.
So in other words, a place like Kenya, you could possibly still buy an HC50, given that you could get it approved because it's certified in the US.
So no, actually, Transport Canada require a full parallel.
No, in Kenya.
Yeah. Yeah,
in Kenya.
Canada
Kenya.
require a full...
Kenya, Africa.
Kenya, Africa.
Oh, in Kenya, sorry. I would have to look at that. If that's a type acceptance territory, which I expect it probably will be, then I'm sure we could accommodate that.
Yeah, it is. And usually you just have to, if it's a new type in the country, then from the CAA they send engineers to the factory on a course and just to get familiar with the type.
Yeah. That'd be straightforward in that case.
Okay. While we're waiting for the next question, yeah, Rebecca, we'll get to you in just half a second. So somebody was asking, they said they just joined live streaming. They were asking what the conditions were again. So do you want to go over those, or do you want me to? Or for the HC50, what the offer is for the HC50
okay,
price?
So HC50 will list at £725,000. And for existing HX50 owners only, they are entitled to purchase an additional aircraft either as a speculation or to increase their fleet with a £50,000 deposit that will entitle them to a £200,000 discount from list. So they'd be purchasing the aircraft at £525,000. And with that, the offer is strictly limited until the 31st of January. And at the moment, we're trying to limit that to UK, Canada, US, South Africa, New Zealand and Australia, just to allow us to manage the rate at which we have to deal with multiple authorities around the world and be realistic about how long that sort of stuff will take.
Okay, perfect. And we just, in the meantime, had another commitment come in for that as well. So, Becca, go ahead with the question.
This may have already been answered and I missed it, but do you have plans to have people available in different countries for training, or do you just expect people just to fly out here for, maybe supplemental training and the initial training?
No, we'll be rolling out support everywhere in the world.
Wonderful.
So yeah, the US, obviously a very big country, there'll be lots over there. Thank you.
Excellent. All right, more questions from the audience, because we have, as Ruben mentioned, over 1,000 people online. We're not going to be able to keep up with the online questions, otherwise we're going to be here till tomorrow sometime. So I think we're going to start restricting those soon and just sticking with the audience questions until the last one, and then at some point or another, we have to break for desserts.
For dessert.
So why don't we go for a couple more questions, and then I think we'll start to wind it down. So
we can wrap up at 7:30, then we can finish that time. So we have about 10 minutes last question.
Steve Brooks,
go ahead.
Steve.
There we go.
What are we looking at? Everybody knows Steve. I have to say this. Steve has impressed me through my helicopter career, let's say, very, very much. He doesn't know this, but I watched his documentary, Pole to Pole. This guy is amazing. He actually, can I say this, Steve? You crashed in the crossing to Antarctica, and he went and did it again. Steve.
Incredible.
Incredible. What a legend.
This man has been to almost every part of the entire globe in a helicopter. It's very hard to beat that.
Go ahead, Steve.
Go ahead.
Well, the helicopter is the most beautiful machine, and to see, everyone's upset about the planet at the moment and how terrible we've been to it, but in the helicopter is the one time when you can see how beautiful our planet is and how unspoiled it. I've just flown to Spain, Portugal, France, and back to the UK and a couple of weeks ago, and how unspoiled Europe is. How fresh the rivers and the forests and the wildlife. And it goes on for hour after hour, and you just wish you could get people to come and join us in our helicopters and see the world as we can see it. Because Mother Nature was just saying, look at me, I'm doing okay here. It was really beautiful. But that was my question. My question was...
Steve, come and sit here.
Well, two questions. One, how can we share the message that what we see from the air of our helicopter, that when we see the majesty of Mother Earth and how beautiful it is, how can we get that message across to people, the sheer scale of this planet compared to when you live in a town and you look out and you see rubbish on the streets and it's really bad, how do we get across the scale and the beauty of the planet?
I think for me, one of the ways that we can do that is the kinds of epic voyages that you've done, that Peter's done, that Ruben and Mischa have done, and then put that out onto the open platforms, to democratize it for people that can't afford to have a helicopter and go and do it all for themselves. And I think when people see what can be done and see what's out there, I think that would be inspirational for people on all sorts of levels. So I think we've not got to be afraid to share the kinds of things that we do and the kinds of things that can be done with these aircraft.
Yeah, absolutely. And to create a beautiful aircraft that is accessible to a larger amount of people.
Yeah, this is it.
So that they can go and experience it for themselves as well.
I think it's a little known fact that between 8,000 and 12,000 people a year globally learn to fly helicopters.
Yeah.
So where do all those people go? You know, and that's not a flash in the pan statistic. That's something that's been around. Where do all those people go? Why aren't they buying helicopters? Mm-hmm. And I think it's all to do with this fact that private owners, the people that buy their own aircraft, feel the big bills. You've got to control the depreciation. You've got to control the operating costs. Mm-hmm. It's really not about the ticket price. It's about that ongoing cost that just drains you in ways that big cars don't. And the whole commercial model with what we're doing here is very much about making it accessible in that way. We looked at the statistics. There are a very, very large number of people that could afford to become part of general aviation. You know, the world has seldom been a wealthier place. There's lots of people that can afford to do this, but you've got to make them want it, and then you've got to make it accessible. And I think that's very much what we're trying to do.
Mm-hmm. Good.
All right, we have time for last 4 minutes. We have many online, but any more from the floor here?
Let's do one more question, I think, from the audience. Let's have one more good one.
Yep.
Yes.
I know that people don't have to decide on the skids and wheels until about a year or something before. But do you have a sense of the ratio between wheels and skids on the orders? How many?
I think it's 100% on wheels, isn't it, Jace?
Yeah. Well,
you don't know what I've decided.
I think when I mentioned that I was putting a 90-knot restriction on the skidded version, everyone went for wheels.
Fair enough.
I think in the early days there was maybe 15%, I think.
Yeah.
But I've kind of lost track because as we've sold more, more people seem to be buying into the idea of a helicopter with wheels. So
yeah, me included.
I've got an outstanding invite to go and talk to the guys at Empire Test Pilot School. And we're going to go and do a few trials and shoot a little video so that we can do the skids versus wheels thing and allow people to see that for themselves that are used to flying skidded helicopters. Mm-hmm. But I think for private owners, there are no disadvantages. Unless your chosen application is to permanently go and land belly deep in the snow or in swamps and things like that, have the wheels, because they just work better for everything. And they make such a difference to the performance of the aircraft. They make such a difference to your ability to maneuver on the ground and to practice emergency maneuvers that for me, it's a total no-brainer. It's a total no-brainer.
And Mischa agrees with that.
What's that?
You agree?
You agree.
Yeah, absolutely. You know, I think it's really an education thing because for me, you know, when I first saw it with the wheels, I thought to myself, I wouldn't get it with the wheels, I'd get it with the skids. But, you know, I think through time, through education, I've seen this as well with a lot of the customers that are contacting us on a regular basis. You know, all of a sudden I start getting photos of people that had chosen that they wanted to have skids, and then they send me a photo of a wheeled helicopter, you know, sitting on a rock somewhere out in the mountains or landed in the snow or these different locations, and all of a sudden it opens their mind because it's a very small, especially in the types of helicopters that we're thinking about here in this size, we're just not used to a helicopter with wheels. And if it is, it's an executive helicopter that goes airport to airport. We're not used to it doing different types of adventure type roles, you know, to land out in the mountains or in your back garden or different places like that. So I think, you know, as I've learned more about it and its capabilities, I've become 100% convinced that for me, you know, for private use, wheels 100%, you know, because Jason's kind of creating that bridge with the removable bear paws essentially, that you're going to be able to still use it in those areas that you would want the skids for, like in the snow and things like that. If you wanted to go heli skiing with it or something like that, you could still do that. You strap them on a few minutes, off you go, and you're going to be able to use it for those applications. So I think realistically, it's going to be a very small amount of demographic for the private use. And I think even for the commercial use, you know, there's going to be certain sectors, of course, that always are going to need skids. You know, if I land on a logging helipad out on the side of a mountain that's built out of 4 pieces of wood, I'm not going to be able to do that with wheels. So there's going to be certain applications where the skids are just a no-brainer. You have to have them. But I think for a lot of operators, they're going to be able to have that flexibility and they're going to be able to use the wheels for the HC. But I think, you know, the ratio is going to flip. I would say we're probably going to see, realistically, maybe an 80-20 split or something. 80% wheels, 20% for the skids in the HX. And that'll probably flip in the HC, I would guess. But it'll vary depending on the industry. Thanks. Yep.
Yeah, so, and I think it's fair game for HC as well, because for HC, we're back to helicopters being used as vertical lift platforms, so the speed's less important.
Yes.
So if it's an executive machine doing charter, then fine, have the wheels, but if you're just lifting vertically, then maybe the bigger track and the ability to land on even worse prepared surfaces is worth it there.
Yeah,
but,
yeah, and for them, exactly, the trade-off for the speed is not as big of a thing because it's a lot more local operations that they're doing. And you know, for them to fly at 125 knots is not that big of a deal with the skid version. So I think another thing that you said to me one time that kind of stuck is interesting. I never thought about it before, but a helicopter with less drag has less issues with turbulence. So if you have a wheeled retractable landing gear, you can have the wheels up, and you're in turbulent situations. You can confirm this if I'm speaking incorrectly, but you're going to be buffeted by that wind less. Because there's less drag on the aircraft.
Yeah, it's the lower projected area. If you've got side gusts and things like that, the skids are a long way away from the mast and the hub that's controlling all of that. So it provides a big surface area to get impacted on by gusty changing winds. So you'll get a benefit from that as well. So it's for me, wheels.
And we're going to do more education on that. I think, you know, as Jason was saying, he's going to do a video. I'm going to eventually get my hands on something that I can fly in the mountains as well, with wheels and skids at the same time, to be able to kind of do some demonstrations on that to see what it's actually capable of. Yeah. So.
All right, we hit to 7:30, right on time as planned, and it was absolutely amazing. So first of all, before I say one really important phrase, after this we're going to have the continuation of our networking. We have our desserts there, and we want to thank you all for coming. It was absolutely amazing to see so many of you in person the first time, and we hope to see you many times because this is a group that's going to continue, and it's really awesome to have people connected with the same vision for a long time, and that's going to be linked with the Hangar 1 first global event. So thank you very much for coming, and last but not least, thank you, Jason.
Yes.
Thank you very much.
Cheers, thank you. And this is the first of many events. There are several events, so we're excited to see you guys again as well. Thank you all.
Thank you, everybody. Thank you for coming.